A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. We shall be starting in a couple of moments. Few of the students are still joining us. Ritika, heat budget is basically an idea about the fact or a calculation about the fact that the total amount of heat received by the Earth's surface equals the amount of heat which is reflected back by the Earth's surface. And the logic which follows this is very simple, that had the Earth been losing lesser amount of heat as compared to what it is receiving, the planet would have been warmer over a period of time. And the converse of it also stands true, that if, let's say, the planet has been losing more heat than what it has been receiving, it would have gotten colder and colder with the passage of time. But such event is not happening. And that is what is heat budget. So that is basically the idea. So for example, if 100 units of solar rays are received, then out of that 27 units are reflected directly back from the clouds. Around 2% is reflected directly by the surface. So overall 51 units are received by the Earth's surface, and eventually by convection, by turbulence, by evaporation, planet manages to lose 51 units of heat, ensuring a maintenance of heat received and heat emitted back. That is the heat budget. Okay, but here again, I would tell you that UPSC has not been asking the question from heat budget in general studies for some time now. And when I say some time, that is more than a decade now. So just have an idea about it, but don't start rote learning it. It is not much of a utilitarian topic for the examination. I hope that is understood, Ritika. Why we require to get heat budget, Vivek? We are not required to get the heat budget. That is just an idea or a calculation about what is the heat received, in what units do the heat receive, or is the heat received by the surface, because significant amount of heat will be dissipated in the atmosphere. And also the surface, whatever amount of heat it receives, how much of it manages to send it back. That is the calculation that we have. So it is a kind of a calculation where we get an idea about the heat received and heat emitted back, so that we get an idea about which process is releasing how much heat. If we talk about convection, how much heat is lost during that. If we talk about turbulence, how much heat is lost due to that. So that is a basis of an ideation. Should we connect each and every static questions to current events in mains? Absolutely yes. That is what makes your question relevant for the or answers relevant for your examination. Otherwise, the answers are very, very theoretical. So this is something that slowly and steadily, when you cover the general studies portion, you get an idea about where to interlink and what to interrelate with. And this is of greater importance in whichever optional subject that you choose. So optional subjects, they have paper 1 and paper 2. It is in paper 2 where you have to put in the application aspect, and that is where you have to interlink it with the theories. So always advisable to interlink. Pulkit, anticyclones are only possible at subtropical high pressure zone? No. Uh, Anticyclones basically wherever, due to upper movement of winds in the region of upper atmosphere, you have a condition where in a particular area the air is forced to sink because of the conditions of the upper air. Due to that also you can have localized anticyclonic conditions created. Ashwant, I got through your mail, and I saw your mail. So it was about you unable to attend few of the sessions. So, see, if you are not able to attend any of the sessions, that is why we have the recordings now. Ideally, the effort should be to attend the sessions live. But if, let's say, you are not able to attend or you have missed out one, it is always advisable that before the entire caravan moves on, you have to make up for that by looking at the recorded videos, and whichever doubts that crop up in the meanwhile should be solved in that process itself. And Shalu, can we say that in cloudy day, temperature is less, whereas cloudy night has higher temperature? Depends on what level of cloud are we talking about, Shalu. So when we are talking about high level clouds or high altitude clouds, even during daytime, it can cause some amount of warming. It is only by reflection of solar rays that it can create a kind of a cooling, and that is observed in low level clouds in general. And please understand that temperature is not always an outcome of a singular phenomena. Temperature in itself is driven by multiple different processes and a continued functionality of different processes like wind movement, etc. But generally, you will find that whenever you have a lot of clouds, the planet surface is not able to release its terrestrial radiation. Debrati, any one newspaper should be enough. Depeche in advection fog, the flow of wind was from warm region to cold region. How? As in, if the question is why and how the wind will move from warm area to cold area, if that is the question, think about when you have the subtropical high pressure belt. And from subtropical high pressure belt, you have a wind going on into the portion of the subpolar low, that is around 60 degrees. So if a wind is originating around 30 degrees, going up till around 60 degrees, is it not an example of warm advection? So that is where it can always end up creating a kind of a foggy condition. Okay. Lakshmi, the atlas work that you give and current affairs places is enough for geography. In the sense of map pointing portions, yes, it is more than sufficient. But see, current affairs in itself is so very vital. For example, if you ask any of the student who has attended my session for the last year, always in the map work, I had told them that look, Ukraine is in news because of Russia Ukraine war. And UPSC is not stupid enough to ask you a question that Russia is indulged in a war with which country? Ukraine, China, Hungary, Belarus, etc. No. UPSC is going to ask you something about that area, around that region. And that is where, when you approach that, and that is what I had also asked many of the candidates to look specifically for the countries surrounding Black Sea, because the grain treaty was important, countries surrounding the portion of Ukraine. So when any area of current affairs is in discussion, you have to look forward around it. For example, Armenia and Azerbaijan, they have fought almost twice in the past 2 years. They have indulged into war, and that was in news because of the fact that for the past couple of years, because wherever wars take place, that automatically comes in news. And it was also relevant to India because India had supplied Pinaka rocket systems to Armenia for usage in that war. So why does that war happen, or why did that war happen? Because of a conflicted region, that is the Nagorno Karabakh area. So always, if that kind of issues are present in current affairs, that is important for the exam. And this year, UPSC has not only asked about Nagorno Karabakh, UPSC has asked about Donbass, UPSC has asked about the bordering areas of Ukraine. So that gives you not the idea that what I'm saying is correct, but what I'm trying to indicate to you is you yourself can initiate and develop that habit, that you get to know that in portions of current affairs which is going to be relevant. Current affairs, if you cover sufficiently, more than significant. Vejri, in sociology also, I will need to connect dynamic and current affairs. Absolutely yes. Absolutely yes. Humidity feel by us these days are relative or specific humidity. So see, Humidity that we experience, it is not specific or relative. It is basically the moisture which is present. How you measure that humidity, how you express that humidity, that is what differentiates it into different types. Okay. Does geography optional isn't scoring one? It is a scoring one, provided that please understand the effort should be that whichever optional that you choose, the effort should be that you should be amongst the top 10 across the country for that particular optional. So with that mindset, if you attack any optional, there is no force which will hold you back in the mains examination. Okay, the effort should not be that I will give the modicum or medium performance, and even in that I will be able to score 300 plus. No. So if you have that kind of a goal, that let's say I take geography, in geography I have to be amongst the top 10, then you are moving in the right direction. Then in that case you have the chances to score 300 plus in geography significantly. Yes, Kishan. Monica, polar high is colder, so it has a high pressure zone, and that is why it is a high thermal high pressure. Yes, that is correct. Almost 55 to 60%. Yes, Mohammed. Vishnu, for map pointing in the optional level, that is something where you have to stick your neck out for any issues in current affairs. And any issues when we talk about in current affairs, you have to understand that at a national level, any tourist place, any place of cultural importance, any mining area, you will have 10 of these map pointing. Ideally, if your preparation is good, you should be able to get around 7 to 8 of them correct, which is very nice in terms of the optional map. Okay. Elias, working professional, provide the or appear start studying about the optional in the weekend at least. No issues, Ashwath. Whenever you are able to write it down, send it to us. What should be the approach in prelim? Because recently the prelims are tougher. Rahul, we had talked about it in detail yesterday about the approach for prelims. And approach for prelims should be as simple as possible. Please don't start your preparation for prelims. Never start your preparation with the prelims aspect in mind. Always initiate the preparation with the mains exam in mind. Now, when you initiate the preparation, let's suppose at that point of time, try to think about it that how do you write your answers. Now, what that helps you is it helps you complete the subject from point A to point Z. And the sooner you are able to finish, the greater number of revisions you will be able to carry. Ideally, before entering into the exam hall, 3 to 4 phases of revision should be carried out. And then start appearing for the test series as early as possible, because that is where improvement lies. That is where temperament is being worked upon. Okay. If you are comfortable in that subject, Monica, you can always take it up as an optional. Okay. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of climatology, where today we initiate the discussion with the portion of temperate and tropical cyclones, and then we will move ahead into the complex phenomena of Walker circulation, El Nino, La Nina circulation, Indian Ocean dipole, Marine-Julian oscillation. So we had initiated the discussion about cyclones yesterday, and we had talked about that what are cyclones, what do we understand by cyclones. So cyclones basically are intense low pressure circulations around which we have a circular movement of wind which is achieved. And that intense low pressure will attract winds from all direction, forming very dense clouds and causing significant amount of rainfall in the process as well. with a lot of strong wind movement, lot of destruction, etc. Now these cyclones, they are basically divided into two different types depending upon where and the regions where they occur. So you have the basic and the primary division into temperate cyclone and tropical cyclone. Temperate cyclones, as the name suggests, occurs in the temperate regions of the world, in the mid-latitude areas of the world. Now, these temperate cyclones, basically you will observe that they occur across a very large area. The areal expanse of it is going to be significantly larger. And why is that the case? That is because these temperate cyclones, they are created over a frontal region. A front basically ends up morphing into a kind of a cyclonic circulation. And why does that happen? We will take a look into it. So every temperate cyclone that builds up, it builds up from a kind of a front. But the vice versa is not true. That means every front will not develop into a cyclone, but for a cyclone, a front is necessary. And because the front is formed over a large area, a deformation of front will also be experienced over a large area. Hence, these cyclones are also formed over a large area. Now, this is directly related with frontogenesis. Wherever you have greater or whenever you have greater frequency of frontal formation, that is where you will have greater frequency of temperate cyclones occurring as well. So here, let's suppose we talk about the frontal formation and the deviation of a front. When is it that it will happen more frequently? During the summer or during the winter? Let us understand that. So when we talk about the winter months, let's consider the temperature. Now let's consider the temperature in tropics and in the poles. After all, it is the tropics which drives the warm air northwards and southwards towards the poles, and the poles which drive the cold air towards the lower latitudes. So during the summer, you will experience that the tropics, on an average, they indicate a temperature close to around 30 to 35 degrees Celsius. That is the on an average temperature, 35 degrees Celsius. Whereas in the poles, you will find that during that period of time, the temperature is around, during the summer months, it is somewhere around minus 10 or minus 15 at max, but minus 5 to minus 10 is where you observe the temperature to lie. And that brings the temperature difference between the tropics and the polar areas close to around 45 degrees Celsius is the temperature difference. Whereas in the case of winter season, while the tropics, they don't become very cold. The tropics, they lose their temperature, but still roughly they are around 25 to 30 degrees Celsius, right? On an average. So here, let's assume 25 degrees Celsius. Now, in the case of the poles during the winter months, you would observe that the temperature sometimes dips to minus 40, minus 45, minus 35 degrees Celsius on the minimum. So that is where, if you consider, let's say, minus 35 degrees Celsius as the temperature around the poles, even though in many areas, in many of the cases, it is much lower than that, what is the difference of temperature that we get in this? We get a difference of temperature of around 60 degrees Celsius. So difference of temperature between the tropical and the polar areas is much more exaggerated during the winter months. That means it is during the winter months when we will have frontogenesis. Frontogenesis is more frequent. Frontogenesis means formation of a front is more frequent. Now, not all the fronts will develop into a cyclone, but if you have more number of fronts, obviously the chances of it developing into a cyclone is also higher. So that is why it is during the winter months, hence more cyclones during winter. During winter. Okay. Now, furthermore, these cyclones and this disturbance, once it is formed, now this disturbance will also end up moving. The cyclones, they have their own path that they end up following. So what is the path that they take and why is it that they move? So let's suppose across, if we consider a planet, if we consider the planet here, right? Let's suppose here you have the middle latitudes. Now, if you have a cyclone which is created here, which is formed here, in general, you will observe that there is the movement of the permanent wind system, which influences the cyclone's movement. Along with that, the Coriolis force also comes into play quite often. But here you will find that the role of the permanent wind system is significant. So when you have the permanent wind system, in which direction will the cyclone move in this region? Let me see if we have revised the tricellular model. Very good. It will move from west to east. This will move from west to east. And that is primarily because it is going to be influenced by the permanent wind, that is westerlies. Westerlies themselves will be carrying this cyclonic circulation from a direction of west to east. So these are your basic features. Now let us quickly recap them and then let us quickly go into the entire formation of a temperate cyclone. Now, by the way, this temperate cyclone is created because of the formation of a front. Now, front can get created anywhere, over land, over water. Hence, this temperate cyclone also can get created either over land or can get created over water also. So can form over land as well as water. Okay. So that is basically where you will observe that it can end up moving in any direction owing to the westerlies, and it can get formed anywhere, be it land or water, wherever there is a frontal formation. Frontal formation will lead to the formation of these cyclones. Okay. Now, after that, if we further move ahead, then basically, a temperate cyclone is also what is referred to as the mid-latitude depression. Depression here always is an indicator of low pressure conditions. Whenever in climatology you come across the term depression, that is basically always considered to be a low pressure system. Okay. Here you have compared with the tropics and poles difference in temperature while we are talking about temperate cyclone. Yes, my dear, that is what I have done. And that is because if there is a greater difference in temperature between the polar air and the tropical air, means the front formation will be more accelerated. And whenever front formation is more accelerated, that is the genesis of tropical temperate cyclones in many of the cases. Okay. So, a temperate cyclone is referred to as the mid-latitude depression, extratropical cyclone, that is beyond the tropics, frontal depression because it is formed across a front, and also a wave cyclone. Why is it referred to as a wave cyclone? Because here, if I can take you back a few slides, if I bring you back to this particular image, you will observe that the frontal formation which will not happen across a straight line. Generally, the frontal formation experiences a kind of a wavy nature in many parts of the planet. And that is because cold air will try to come in to the warmer areas and the vice versa also holds true. So that is where you will observe that it is referred to as a wave cyclone. Then, They are active above the mid-latitudinal region between 35 to 65 degrees in both the hemispheres. Direction of movement of the cyclone is from west to east and is more pronounced during the winter seasons. Why? Because during the winter months, you have a greater difference of temperature between the warm and the cold air. When you have a greater difference in temperature, that means the front formation will be very, very significant. If you have lesser difference in temperature, the front can quickly dissipate or frontalysis can happen. But if you have greater difference in temperature, that means it will sustain for a long period of time. So that is why when we say more frequent during winter season, because of greater difference between temperature of warm and cold air. Okay, so frontal formation is going to be basically much more pronounced. So as a result of that, fronts are more pronounced. Hence, there is a greater probability that some of these fronts will develop into a kind of a temperate cyclone. Okay, hence you have the greater amount of cyclonic circulation or more frequent cyclonic circulation during the winter months. Now, it is here across these latitudes that polar and tropical air masses meet and they form the fronts, and that is where it can develop into a temperate cyclone. Pronounced here refers to being more accentuated or rather being more predominated, or in simpler terms, if you have to think about it, frontal formation is much more frequent. Now, here, after this, let us try to understand that how a cyclone builds up. What are the characteristics and why is it that the low pressure gets so significantly aggravated that a cyclonic circulation develops around it? Let us understand that process step by step with the help of the images. So, starting with, first of all, when we talk about, let's say, the initial stage, the initial process. So, initial process basically is that warm air and the cold air, they come across each other, they come in front of each other. But in the initial stage, you do not have the warm air or the colder air having increased capacity to break into each other's region. So in the initial stage, what will be formed is a kind of a stationary front. Initial stage, you will observe the stationary front. Okay. Now, that stationary front, when it is formed, after a period of time, we have seen that if, let's say, there is no further movement which is achieved or which is observed in that region, after a point of time, it also can happen that the warm air gains some property of the colder air, cold air gains some property of the warmer air, and frontalysis can happen. Now, here, let me know one common logical point that I'm going to ask you. Apply your logic here. Now, if I have a cold air, and all those of you who are asking question that why during winter only it is going to be more prominent. So for all of you, I have written here multiple times that is because of the winter, and during the winter, you will have greater amount of difference in temperature. Hence, there is a greater chance of frontal formation. Now here, when we talk about, let's say, cold air and warm air, if the cold air, let's say, has a temperature, cold air has got a temperature of, let's suppose, 0 degrees Celsius, and warm air in this case has got temperature of, let's suppose, 10 degrees Celsius. Okay, let's assume. In the other area, in the other case, this consider it as case A. In the other area, for example, you have cold air with a temperature coming from the polar region. So cold polar air, let's suppose indicating a temperature of minus 10 degrees Celsius. And let's suppose we have the tropical air or the warm air supplied from the tropics. Let's suppose I have the tropical air. And that tropical air's temperature in this case is, let us assume, 20 degrees Celsius. Now, in the first and the second cases, in both of these cases, frontal formation will be observed. A stationary front is created. Now, out of these two cases, where do you think that frontolysis is more prominent or more probable to experience? Out of A and B, where do you think frontolysis will be, not frontogenesis, frontolysis? Where do you think frontolysis will be a more common phenomena? I'll do one thing. I'll launch a poll here for 15 seconds. Let me know so that I get a clear-cut view. Where is it that the frontolysis will be more prominent? Hmm. So we have almost equal distribution. That doesn't solve our case, does it? So what is frontolysis? Frontolysis is a dissipation of the front. When the front ceases to exist anymore, when you don't have the difference in temperature anymore, that is when you achieve frontolysis. Frontolysis is referred to as the death of a front. So when does the front die? When the air becomes homogeneous, when the air gains each other's properties very easily, and you have a common uniform temperature which is observed, which is gained. Now, in the first case, the difference in temperature is how much? 0 degrees C and 10 degrees C. So the difference in temperature is 10 degrees Celsius, isn't it? So here, in the second case, what is the difference of temperature? It is 30 degrees Celsius. So where is it that homogenization of air is much easier? It has always been the first case where the difference in temperature is less. So it is very easy for the colder air to, or the polar air to gain a temperature by 5 degree and the warmer air to lose the temperature by 5 degree. Whereas in the second case, you will observe that you have a significant amount of difference of temperature which does exist. Okay, so that is why frontolysis will be very little in the case of the second scenario, whereas frontolysis will be more prominent in the first case. And that is basically again telling you that why is it and how is it that stationary front can sometime develop into a cyclone, whereas stationary front on the other cases can develop into or can basically dissipate as a process of frontolysis. So this stationary front, either of them can gain energy, either of them can become more powerful. You can have the cold air becoming more powerful, you can have the warm air gaining more energy. Anything can happen, or frontolysis can also happen. But when you have the conditions of development of a cyclone, you will observe that initially, after some time, after spending some time in the case of the stationary front, the cold air starts to push in into the warmer areas, and warm air starts to push in into the colder regions. Right? So that is where the front starts to deform. Okay, a couple of things for let me announce in the class, and I'm not going to take the name here. Please try to follow the session as the speed is going. Please don't try to dictate the speed, that the speed is slow, speed is fast, speed is very fast, or speed is very slow. Whatever is the pace being covered in the class, kindly cover with that pace only. Okay, and please don't start to command or have a demand that this should be the speed. You are not the only individual attending the session. Please understand that it is not a one-to-one session that we are addressing. I hope the individual who has been flooding the comment section is smart enough to understand for whom it is being directed. It is up to us to finish the syllabus in a judicious manner. We will achieve that. Okay, we will finish the syllabus. We know how much priority has to be given in which particular areas. If you are very, very comfortable with the topic, think about it as a source of revision. If that source of revision is much boring for you because you have a lot of information, you are free to look at the recorded session at maybe whatever speed that you want to look at. But let this class carry out in a kind of a peaceful manner. I hope that is understood and that is taken as a particular note of importance. Now, here, when you have in the initial stages, let me again initiate. When you have the initial stages, in the first stage, the cold and the warm air come in front of each other and they end up developing a stationary front. That front can get deformed. Now, when that front gets deformed, it can lead to formation of the multiple fronts at the same time. How? Let's suppose from this area, cold air starts to push in. So here, as the cold air starts to push in, it basically ends up creating a kind of a cold front here. And here, let's suppose warm air starts to push in. Here in this area, it will form a kind of a warm front, isn't it? So in this case, observe that in the second stage, basically, the front gets deformed quite significantly. So at one area, here you will observe that the cold air is pushing in. In this area, it is the warm air that is pushing in, isn't it? Now, both of them are pushing in each other's direction. When you have a cold front, which air rises up? It is the warm air. When you have the warm front, which air is pushed up? Again, it is the warm air. So, be it the cold front or the warm front, in either of the cases, you will observe that warm air is pushed up. So from the stationary front, then when we come to the stage 2, here you have development of two simultaneous fronts. You have the development of two simultaneous fronts. On one side where the cold air is pushing, you have the cold front. On the other side, you have the warm front. That is cold front and warm front. Now, when you have the cold front or the warm front, in either of these cases, you will have the warm air which is getting lifted up. So if let's say the cold air is attacking from this area, cold air is trying to progress from this area, warm air is trying to proceed from this region, that means in this vicinity, in this small region, we are experiencing a significant rise of warm air. So in both these cases, we have significant rise of warm air we have the case where you experience a significant rise of warm air. And whenever you have significant rise of warm air means what? It means it will end up creating what kind of pressure condition on the ground surface? where you have the rise of warm air, it will end up creating a low pressure on the ground. Okay. So again, here I want to take a look at this again. Observe how from the basic formation of a stationary front, how you will observe that from one area you have the cold air which is pushing in, from another area warm air is pushing in. So if you think about it, let's suppose this was your earlier stationary front with cold air in one region and warm air in another area. Now let's suppose warm air becomes active in this area and starts pushing in. Cold air becomes active in this area and starts pushing in. Now, what will it lead to? It will lead to a deformation of the front. The front will become somewhat like this, where cold air would have come up till here, and that would have led to the formation of a cold front in this case. Cold front in this case. And here you would observe the warm air pushing in, so formation of a simultaneous warm front will also happen. And in both these areas, you have the rise of warm air, creating the condition of low pressure. So when you have the development of this low pressure, observe that this low pressure brings about more winds. Wherever you have the presence of low pressure, it will attract more winds. It will attract more polar winds also. It will attract more tropical winds also, right? Both of these winds will combine or will come together at the subpolar or the subtropical region. Now, greater the low pressure, more winds will be attracted. More winds will be attracted means the front will get deformed furthermore. So, in the region around that low pressure, let's suppose this is the region around that low pressure, you will observe that here, let's suppose this is the area where the cold air has been pushing in, and this is the region where the warm air has been forming a kind of a front here. Okay, let's suppose this is the warm front. This is the cold front. In this region, you have the cold air. In this region, you have the presence of warm air. Here, that cold air is pushing, and here the warm air is pushing ahead. Now, as a consequence of that, as a result of that, what will happen? Warm air is rising up, and across the cold front, warm air is being pushed up. So you will observe a different type of weather conditions across both these frontal areas. But as these winds are rising up, they will develop a kind of a circulation pattern around this low pressure. Why? Because of Coriolis force. So that is where the winds, as they rise up, they develop a very large circulation, and they rise up in a kind of a spiral manner also. So that is why you have the circular formation. Now, in this case, across the cold front, the weather experienced will be, when we say the weather experienced will be what? What is the weather experienced at the region of a cold front? What do you think? Any of us who recall that? Across a cold front. Very good. You have thunderstorm and heavy rains. Whereas when we talk about the warm front will have what kind of a weather condition? Warm front, basically you will observe moderate and steady rainfall. Moderate and steady rainfall will be experienced. So, at the same time, across the two ends of the front, across the two sides of the front, you will experience the formation of a simultaneous cold front, formation of a simultaneous warm front also happening at the same time, right? And in all this process, in all this entire mayhem, you have the warm air which is being pushed up, and that warm air is rising around that low pressure, forming that circulation. So here, basically, rising air around the low pressure develops a cyclonic circulation due to Coriolis force. Due to Coriolis force. Okay. So now, after a point of time, what will happen? Slowly and steadily, because the low pressure is present, cold air will start replacing the warm air from the ground. Because as we have the intense low pressure, think about it. It will attract both warm air as well as cold air. Both of them will intermix, much of that will rise up, but on the ground surface, warm regions or warm air regions will be replaced by the cold air because the cold air will be hugging and sticking to the ground surface, lifting the warm air. So, slowly and steadily from all sides, even if the warm air is active, it is immediately rising up. It is immediately observed. It is getting pushed up. Whereas on the ground, from all around it, the cold air is replacing it slowly and steadily. That is what gets accentuated. And slowly and steadily, you will observe here that on the ground, around this low pressure, the cold air starts surrounding it. That is the beginning of the stage of occlusion. So, what is this stage? So, due to low pressure, intense low pressure, more winds are attracted. When you have more winds which are attracted, that basically means what? That means slowly and steadily, the colder air will start replacing the warm air from the ground, whether it is the warm front or the cold front which is formed. So, fronts will be active and be it the cold front or warm front, warmer air is pushed up from the ground. Now, even at this point of time, you will come across significant amount of disturbance. You will come across the disturbance in the sense that here also across the cold front, the warm front, there will be different weather conditions. And imagine in this area of low pressure, where you will have a combination of both those phenomena and the air rising up quite significantly. It is at that region of low pressure where you will have a lot of destruction and devastation being carried out. But the wind movement will be experienced in that entire region. You will experience a wind movement or a wind portion. Now, after this, observe here the warm air is being pushed up here, the cold air is pushing on the ground. So observe the region which was earlier dominated by warm air on the ground, how that region has actually shrunk in size. It has started getting narrower because, regardless of the warm or the cold front, it is the warm air lifted upwards, cold air is sweeping the ground. And that eventually leads to the occlusion or the dissipation of the cyclone. So, overall, that condition or situation is reached when the warm air is completely lifted off the ground. And then you have nothing but cold air on the ground surface. So, if around that low pressure, now you have the presence of only that cold air, no frontal formation, it will cause some amount of maybe rainfall, latent rainfall, whichever is left over. But after this, dissipation happens because the front is not prominent anymore. It was the frontal formation which was initiating the rise of the winds. And here you don't have the presence of the front anymore. The front has actually closed. And that is what is referred to as occlusion, the process of the front closing up. That is what is referred to as occlusion. So that is basically what you experience in the case of a temperate cyclone. This entire process that we have talked about, I will very quickly give you a recap as well so that the materials they cement in your mind. See, it all begins in the initial stages with the development of a stationary front. Stationary front will have the case where the warm air pushes in from one area, cold air pushes in from another region. Now, slowly and steadily, the front starts getting deformed. Once the front gets deformed, here, why? Because maybe the cold air gets activated, maybe the warm air gets activated in a region. So that is where the front gets deformed. You have the simultaneous creation and formation of both the warm and the cold fronts. Across both these regions, we start experiencing different weather conditions. And be it the warm front or the cold front, it is the warm air which is basically being pushed upwards continuously. And as the warm air is continuously being pushed up, wherever you have a rising air column on the ground surface, you have the presence of low pressure, which is created. Rising air column always is associated with the condition of low pressure. And after this, you will observe that slowly and steadily the cold air starts gripping it from all different sides and observe that the low pressure intensifies. But in the process, the front starts to close because the cold air starts replacing the ground presence of the warm air. And that is how eventually you reach the stage of occlusion where the front is completely closed. Now, at this stage, you don't have any rising air at the region of low pressure. Why? Because at this stage, you don't have any presence of warm air in the region around low pressure. So, no frontal formation at the region of low pressure. So, at the region of low pressure, at this stage, you experience frontolysis to happen, or dissipation or the death of the front to happen, which marks the end of the cyclone. The entire process can take close to around 15 to 25 days, right? So it lasts for around 2 to 3 weeks in general. The wind movement that you experience, wind movement is fast, but then it is not very fast and devastating as you will observe in the case of tropical cyclone. It covers a very large area. Now, you know what? The climatologists, just by taking a look at the development of the low pressure, the availability of warm winds and the cold winds, climatologists are oftentimes able to predict that, okay, if the low pressure, let's say, is 990 millibar or 950 millibar, that means XYZ will be the intensity of the cyclone. Means you will have that many winds will have that much speed, etc., etc. The climatologists will be able to have a prediction. But sometimes what happens, due to various factors, due to factors such as sudden rush of wind in one direction, and that means increased rising up of the wind in one particular localized area. Sometimes it can also happen that while this process is basically unwrapping itself, it might happen that there is increased heating of the ground or the water around the low pressure. So that would mean further enhancement of the rise of air. So when you have such sudden significant rise of air which is initiated, what do you think will happen to the intensity of low pressure? Intensity of low pressure, will it increase, or will the low pressure get vitiated or dampened? Very good. Intensity of low pressure increases due to these processes. Now tell me, if the intensity of low pressure is increased, is very high, what do you think will be the wind movement, rainfall, cloud conditions, devastation associated with it? Will it be higher? Will it be lower? It will be very high, isn't it? So that is when all of a sudden, sometimes what happens is that the pressure in that low pressure region, it intensifies by more than 24 millibar within one day. It gets more low pressure and it intensifies by more than 24 millibar. So as a result of that, cyclone suddenly starts becoming much more intensive, and that is what we refer to as bomb cyclone. Bomb cyclone is what is a suddenly intensified cyclone. So it involves a drop of 24 millibar or more of pressure within the span of 24 hours. This sudden intensification has got its own ramification in terms of wind movement, in terms of rainfall, destruction, etc., which is created. So basically, that entire formation where you have the sudden intensification of the cyclone, that is what is referred to as bomb cyclone, and that process is referred to as bombogenesis or explosive cyclogenesis, or the birth of an explosive cyclone. This is mostly observed in temperate cyclones. Mostly this is a phenomena prominent with temperate cyclones, and sometimes you will also come across that sudden intensification of low pressure in tropics, but it majority of the cases it is a phenomena associated with temperate cyclones. So bomb cyclone is not a new cyclone. It is the existing cyclone which has suddenly intensified beyond prediction. And intensified by how much? Just like in the case of cloudburst, we had a clear cut lineation that if XYZ amount of rainfall happens within 1 hour, maybe we declare it as a cloudburst. Similarly, here also, if the low pressure intensifies by more than 24 millibar, if within one day, you have sudden intensification of cyclone referred to as bomb cyclone. So that low pressure can get intensified by the sudden process of accelerated wind movement, can get intensified due to the mixing of the heat in the process, where the significant amount of heat also exaggerates the conditions of the low pressure. So in either of these cases, or due to either of these cases, you can have the generation of the presence of bomb cyclone. Okay. Now, after this, we come to the portion of temperate cyclone. Now, when we talk about, or we come to the portion of tropical cyclone. Tropical cyclones not only are the ones which impact us, but tropical cyclones are important for your examination also, because this is the one which influences India. India doesn't experience the formation of temperate cyclone. India experiences the formation of a tropical cyclone. Now, these are also referred to as tropical storms, tropical disturbances, and so on. Now, here, observe the circulation. The circulation is not very large, not as large as you observed in the case of a temperate cyclone. The circulation is restricted into a smaller area. So, here, that circulation, even though restricted to a smaller area, can initiate a lot of associated damage, is always referred to be more devastating and more destructive than any temperate cyclone. Here, the wind speeds are very, very high. But the process of formation of a temperate cyclone is, or a tropical cyclone is completely different from what we have seen in the case of temperate one. Here, there is no frontal formation which is observed. Okay, here basically the cyclone has got the ability to generate heat on its own and intensify in on its own. That is why, as we will see, this tropical cyclone is what is also sometimes referred to as a heat engine. Now, this tropical cyclone basically can be experienced in tropical areas or tropical waters across the world. It is not only restricted only to India, but here you will not find the presence of this cyclone at the region of equator. No formation of this cyclone at equator will take place. And the reason is very simple. That is because at equator, Coriolis force is zero. Now, if the Coriolis force is zero, means you don't have any circulation which is achieved. And no circulation achieved means no cyclonic formation here. So that is basically the tropical cyclones. Now, here, because they are formed in the tropics of the world, they are known by different names. For example, when they are formed in the region of Indian Ocean, they are referred to by the names of cyclones itself. When they are formed in the region of Atlantic and some parts of Eastern Pacific, they are referred to as hurricanes. When you have the presence of these formations in the region of Western Pacific and South China Sea, that is what is referred to as a typhoon. And when the same formation happens around the region of Northern and Western Australia, we refer to it as willy willies. So there is the different local name which exists in different areas for this tropical cyclone, its germination, its birth, and its development. So, this is the spread all across the tropical area. You will experience the formation of this. Now, why does it develop? How does it develop? In the case of temperate cyclone, we had seen that you had the development of a front, and that front started distorting, and that led to a significant rise of air, and that brought about a cyclonic circulation and a cyclonic rainfall. But in this case, how is it that this is generated? So, this is generated because of the basic condition of thermal low pressure. Low pressure developing over water bodies. Thermal low pressure developing over water bodies. Right. Now, water bodies where in the tropics. And that thermal low pressure sometimes will intensify into a cyclone, but not always. So you need a few conditions to be fulfilled for that low pressure to develop into a cyclone. Let us take a look at those conditions, that when is it that a cyclone can develop? Which are the conditions which need to be fulfilled? But before that, how many of us, we have no clue about latent heat? Latent heat of condensation, latent heat of vaporization, latent heat. We have no clue what is latent heat. Okay. So when we talk about latent heat in general, it is the amount of heat which is consumed or which is given out by any state of matter in order to convert from one state to another. For example, here, let's suppose you take any kind of a solid. Let's suppose ice. Now, if you take ice, the particles, the molecules, they are arranged in a crystalline structure. They have the bonds which are present. Now, if I heat it up, the temperature will rise. Let's suppose the temperature initially was minus 10 degrees Celsius. I heat this ice up, temperature begins to rise, right? Around 0 degree, I continue to provide heat, but the temperature doesn't show an immediate rise. Because that heat which I am providing at 0 degrees Celsius, that heat is being consumed by the matter to break these bonds. Because only after the bonds are broken between the molecules, that is when a solid will get converted into liquid. And in the case of liquid to gas, again, the bonds need to be broken. So in both these cases, for the breakage of the bonds, you require heat energy. But that heat energy which is required, which is provided, doesn't imply itself or exhibit itself on a thermometer. There, you don't experience a temperature change. So at 0 degrees Celsius, water can exist in liquid, very cold water, and it can exist in ice also. So that heat which is consumed in the process is the latent heat of melting, because you are getting that heat to convert the state of material. Similarly, think about it that we consider a gas, water vapor. Now, if I cool it down, if I drop its temperature, slowly and steadily, the molecules will come closer. But that is not enough to get converted into liquid. Eventually, for getting converted into liquid, let's suppose I've cooled the temperature to significant proportion. Now I have a lot of molecules. But in order to get converted into liquid, they will start re-establishing the bonds. As I further cool them, they will start re-establishing the bonds to get converted into liquid. And in the process, they will release heat. And that heat which is released while the state of matter is being changed from gas to liquid, that is latent heat of condensation. Okay, so latent heat of condensation. So whenever cooling happens, let's suppose gas condenses to liquid, heat is released. And that heat which is released is latent heat of condensation. Now, here you might be thinking that why all of a sudden we were talking about cyclone, all of a sudden we are talking about these physical quantities. That is because this latent heat of condensation has got a very important role to play in the entire formation of the tropical cyclone. So once we are aware of this, let us move ahead. First of all, by familiarizing ourselves with the conditions which are required for the generation of this tropical cyclone. What are the conditions which need to be fulfilled? So the tropical cyclone requires for the development a large sea surface with temperature higher than 27 degrees Celsius. This is not going to be formed over land areas. This will be formed only over the or over the sea surface. What is the reason for it? We'll come to it. But you need a large sea surface. Now, here again, please don't get into the kind of a phenomena that or a habit that I have a pond in my backyard. There also the temperature rises, so I don't see a tropical cyclone forming. No, we are talking about very large water bodies. So I understand the follow-up question will be, but in my area the river gets very wide during the rainy season, so that is as good as a sea. The locals tell that it is one of the widest water bodies ever in the world. Still, no tropical cyclone. For tropical cyclone, seas and oceans in the tropics and the tropical areas. So, if the temperature increases higher than 27 degrees Celsius, that is when you have the germination of the tropical cyclone. Now, here, you also require the presence of the Coriolis force. Coriolis force is required why? In order to attain circulation, in order to achieve circular movement of air. And that circular movement of wind or air, that is very much essential in the way how the clouds are created. How the clouds initially are created in the central portion, and slowly and steadily they expand and they are pushed on the outside. Then another required condition is small variation in the vertical wind speed. That basically means vertical wind speed here refers to speed of wind at upper altitude and the ground surface. Okay, so this basically means there should not be much of a difference between the wind speed at the ground surface or at the sea level and the upper altitude. And what is the reason for that? The reason is, let's suppose in a particular area, if you have development of a cyclonic circulation, let's say the clouds are getting formed because of rising air. Let's suppose. Now, if the upper altitude or the upper atmosphere wind is very strong and lower atmosphere wind is not that strong, means what? All these clouds will immediately be carried away. And that is not required for a tropical cyclone's development. A tropical cyclone's development requires the cloud to stay in that region of low pressure, and slowly and steadily they end up moving along with the entire disturbance. They end up moving ever so slowly. So then that is why if you have lesser difference of speed at upper altitude and the sea level, greater chances of formation and intensification of a cyclone. Then a pre-existing weak low pressure area, that is, if you have a pre-existing low pressure area, that basically means that it can always intensify into a cyclone. So that is which is present. The third point, that is small variation in vertical wind speed, it basically indicates that there should be lesser difference in the speed of the wind at the ground surface and as compared to the upper altitude where the clouds will be created. Because if there's a greater wind speed in the upper atmosphere and the at the ground surface if the wind speed is very slow, so whatever clouds are created due to this, that will be carried away and the cyclone won't intensify in the process. That is why you need a small variation. Now after this, let us take a look at the formation process from scratch. Let us understand how is it that the formation happens. And here again, I would like to reiterate that in both the cases, that is temperate as well as tropical cyclone, whatever basis of concept that we are laying here, try to inculcate that concept by writing it immediately after the class, because you don't find that detailed conceptual clarity in the books. In reference books you will never come across. In case you want to revise these concepts, I would advise you to only look at the tablet recordings that you have, the tablet lectures of climatology. That can also serve the purpose, but basically use it for revision. But don't get confused by looking at the various different reference materials, because many of the reference materials, they will put various different contents in a hodgepodge manner. You might end up getting confused in these critical portions of climatology. So let us understand first of all the process of formation. Formation. Let us understand why is it that it will be created only above the water body. So here we require a large sea surface area, right, which has got an intense low pressure. Let's suppose here we have the development of a low pressure. Because of heating, let's suppose because of heating, the temperature has increased, and it has increased beyond 27 degrees Celsius, and it has led to the formation of that intense low pressure. Now, when we talk about this low pressure here, if you think about it, it will attract winds from all directions. It will attract winds from all directions, isn't it? Now, these winds, what can we say about the characteristic of these winds? They are in the tropical areas, so they are warmer. They are coming over large water bodies, so the moisture content will be very, very high. Now, these winds, when they come over this low pressure area, they will also get heated significantly. They will start rising up, and they rise up in a spiral manner. They rise up in a kind of a spiral manner. Now, as they rise up, their temperature will start to reduce, isn't it? Temperature reduces with the increase in altitude and the rise of air. So, as they rise up, the temperature reduces. Now, for a brief moment, pay attention here. Let's say in a particular area, you have the rise of wind straight up, vertical. So, as it loses temperature, it will form clouds. But let's imagine if the wind is rising in a spiral manner, all around in a circular portion. Now, the cloud formed will be basically on the sides of the spiral, isn't it? Imagine that the spiral that the wind is creating, that spiral, if you imagine it somewhat like this, that this is where the wind is basically rising up across the spiral. What do you have? That the cloud formation will happen across all the sides of the spiral, isn't it? So, something very similar happens here also. Here also, you will observe that as this wind starts to rise up, it loses temperature. But then, it is as it loses temperature, it will cool down, attain saturation, it will condense, lead to the formation of clouds all around that spiral portion. And that is where initially the clouds are created, around the spiral. Obviously, I can represent it in a two-dimensional state only, but I hope you understand that all around the spiral, you will have the cloud formation with a gap in between because the air is rising in a spiral manner. So this is how you have the development of the clouds initially. Please understand how these clouds appear to look like is somewhat like this, where this is the spiral that we are talking about, where the wind is rising up all around it. You have the cloud formation happening around the spiral. Now, when the cloud formation is happening, we can refer to it as a mode of condensation, isn't it? We can refer to it as condensation happening. Whenever condensation happens, you have latent heat which is released, latent heat of condensation. Where is the condensation happening? All around the spiral. So, where is it that latent heat will be released? Latent heat will be released here within the spiral. Here you will observe that latent heat is released. release of latent heat. Okay, now as a result of that, already in the central portion, because the latent heat is being released in the central portion, you will already start experiencing slightly higher temperature. Now, in this case, observe another phenomena. As we have the winds rising up in a circular fashion, something unique will happen in the central part of it. What? So, for this, I would want you to think about your, let's say, childhood days when you would play with a bucket of water and so on. I'm sure now we are very sophisticated, we are very suave and genteel, and we have a very polite manner of operating. But let's assume in your childhood days you would have played with water relentlessly. I'm sure most of you would have observed or done this, that in a bucket full of water, let's suppose, where the water is full up to the brim, you put your arm around the side and you try to rotate that water, creating your own conditions of a whirlpool, isn't it? Most of you would have done that. That you rotate the water significantly on the sides of the bucket to observe that how the whirlpool looks like that you see in the movies and the TV, right? Now, there, when you do that, what did you observe about the water level on the sides where it is rotating? Water level on the sides, does it rise up? Does it remain the same, or does it fall down? It tends to rise up, isn't it? So you have a rising whirlpool of water on the sides that you have created. But what happens in the central portion? In the central portion of the bucket, what happens to the water level? Does it remain unimpacted? Does it rise up? Does it fall down? It falls down sufficiently. It creates almost like a depression, doesn't it? So, air in this case also behaves thus in the same manner. On the sides, as you have a strong rising whirlpool of air, in the central portion, what will happen? There will be a kind of a sinking, a kind of a suction impact which will be created. And that means in the central portion, you will observe air from all sides to be pulled in and directed downwards, right? Because the same suction that you observed in the case of the water, something very similar will be created here. Now, once this suction is created, air is forced downwards. Air starts subsiding downwards. Now, when the air subsides downwards, in that case, what will happen? All that latent heat which had been accumulated in the process of the cloud formation, all that latent heat will be captured by the air as it starts to sink in. Now, when the air sinks in, can we say it is coming from a region of lower air density to a region of higher air density? So, what will happen in terms of the volume of air? Air will get compressed, isn't it? When air gets compressed, that is the adiabatic compression, there will be a warming which will follow. Significant amount of warming will follow. So the air undergoes adiabatic compression, and then means temperature will increase. Means what? This low pressure that you observe, that will get much more heated up, isn't it? So here, the sinking air basically will bring about a greater amount of heating. The low pressure will get more intense. Now, when the low pressure gets more intense, means what? It will attract more winds. More winds will cover the oceanic areas, the vast regions of the oceans. And because that low pressure is much more intense, it is much more hot, that is why it will attract winds from all sides. All these winds are carrying nothing but moisture. Now, when these winds also get heated up, they will also start rising up the spiral. When they rise up that spiral, they will lead to the formation of those clouds on the sides of the spiral. So, when the clouds are formed there, the existing clouds basically will be pushed aside. The existing clouds will be pushed aside, and these clouds will have a kind of an extension. And the clouds will grow larger. So the cloud formation will be observed. Across the central portion, it will start to expand outwards. Right? That is how the entire circle develops. And this cloud, when it is getting formed, it will again release that latent heat of condensation. That latent heat of condensation will be brought down by the sinking air. And that sinking air will get further heated up, will further heat up that low pressure region. Low pressure will get intense. And as the low pressure gets more intense, it will attract more winds. More winds are attracted means what? More rise up of air will happen, and this process will repeat itself. So, this is how, on its own, without any outside interference, a tropical cyclone is not only able to sustain itself, it is able to get stronger and stronger and stronger. And here you would have observed that the entire circulation is able to generate heat on its own. That is why this entire process is what is also referred to as a heat engine, because it is able to generate heat on its own. And that is why, longer the time that a tropical cyclone stays over the water body, greater will be the intensification and more powerful it will be. Lesser the time the tropical cyclone spends on water, weaker it will be. So let me write down a few things so that it is easier for you to revise. So first of all, you have low pressure, right? Now attracts moist winds because it is water. Moist winds, they rise up and then undergoes condensation. Whenever condensation happens, you will have latent heat of condensation will be released. Latent heat of condensation is released. Now, this latent heat of condensation will increase the temperature of the central portion, increases the temperature. As a result of that, you will experience what? Intensification of the low pressure. Of low pressure. When you have intensification of low pressure, it will attract more moist winds and the cycle repeats itself. Here it is able to generate heat on its own. Why? Because that latent heat of condensation and the presence of sinking air. So that is why this is also what is referred to as heat engine. Now this entire process is driven from the basic factor that when you have these moist winds, greater amount of condensation will happen always. Moist winds mean greater condensation. Greater condensation means greater release of latent heat. Okay, always. So had this formed over the land area, let's suppose, had this low pressure been formed over the land area, the low pressure would have attracted winds. But Would they have so much amount of moisture to release that much amount of latent heat that it could sustain the cyclone? The answer is no. That is why it is pertinent, it is important for this cyclone to be formed, or the important factor is that this cyclone can be formed only over the water body because it needs that much moisture in order to sustain itself. Now, the central portion, this particular area, this is what is also referred to as the eye of the cyclone. Eye of the cyclone. In the region of the eye, you don't experience any cloud formation. No cloud formation. No cloud formation will be observed here. Why? Because, first of all, here the temperature is higher in the central portion. So, because the temperature is higher, condensation will not take place. Condensation takes place at lower temperature. And secondly, here you have the sinking air column which is present. So as the air starts to sink, in any area where you have a sinking air column, there you will never come across any kind of cloud formation. So no cloud formation will be experienced here. The sides of it, this is what is referred to as an eye wall. So in the case of the eye, you will have clear sky, right? You have the sinking air column. Whereas in the case of the eye wall, you will have very dense and thick clouds, right? Very dense, thick cumulonimbus clouds. They are present all around. Now here, when we talk about, let's say, how is it that this cyclone ends up getting dissipated? How is it that it weakens? So this cyclone weakens or dissipates as soon as it hits the land. That is where you will observe the tropical cyclones. When they hit the land, within a couple of days, they disappear, they dissipate. Why? Because that supply to moisture, that gets cut off. That cyclone is no longer provided with moisture. As a result of that, no latent heat of condensation will be released. As a result of that, no intensification of low pressure will be observed or experienced. So, how is it that dissipation happens? Why is it that dissipation happens? So, for example, here, let's say we have a landmass, suppose. Now, this cyclone in itself will also be carried by the winds which are present, the entire circulation. Now, that is why if you take a look at the third condition for the very necessity factor or necessary factor for the development of a cyclone, small variation in vertical wind speed. Imagine if you would have had a very strong wind in the upper atmosphere and very weak wind in the region of the sea surface, you would have observed that all these clouds are blown away. So that latent heat of condensation is no longer able to provide a significant heating to that low pressure. And without heating of that low pressure, cyclone would have dissipated very quickly. That is why that conditionality requires to be fulfilled, that the upper air wind, lower air wind, the velocity is almost similar so that the cyclonic formation is sustained. Now, as this cyclone, let's say, moves, and you are an individual having a jolly good time on the beach, relaxing after the prelims exam. That, anyways, the next exam that I have to appear is next year's prelims. So, why not relax for the next 6 months? So, let's suppose you are relaxing after the prelims examination, after your wonderful examination on the beach. Now, you observe a cyclone appearing. Now, first of all, this cyclone will have an associated wind moving in that entire region of disturbance. The first impact that you will experience is when these clouds, observe the image, when these clouds basically they make an impact. When these clouds they will hit the region, it will cause tremendous rainfall, very strong winds, tremendous rainfall. Then comes the eye wall. Eye wall will bring very stormy conditions, heavy spell of rainfall, right? Thunderstorms, lightning. And because the clouds are so very thick here that heavy rainfall can sustain for multiple hours altogether. And after that, the eye comes over. That is when we say that the cyclone has finally made a landfall. The eye comes over to the land. When the eye comes over the eye, you don't have a cloud cover. And there will be no cloud cover. There will be actually a clear sky. So you will be able to observe the clear sky. And many of the optimistic people think that, okay, this is the end of the cyclone. I have basically, faced the cyclone in my good time and nothing happened. And I is where you will have bright sun, lack of wind, etc. It will exist for a few hours, but the entire system is moving forward. So after the eye and during the eye of the cyclone, that is when majority of the people they start coming out of their houses. Because when the cyclone warning is given, everybody tries to stay within the house. But when that rainfall stops and the eye comes over, people mistake the sunshine received during the eye to think about it that the cyclone has dissipated. Majority of the people come out. And that is when the second part of the cyclone, that is the eye wall and the other, that makes the landfall again. And it again brings in very similar conditions, a very high level of wind movement, stormy conditions, very heavy rainfall, leading to flooding, etc. Now, as the eye makes the landfall, thereby, let's suppose that low pressure region has shifted here. The eye has shifted somewhere here. Now, in this case, it will attract winds, but the winds won't have moisture because the winds are coming from the land areas. So when they don't have moisture, that latent heat of condensation won't be released anymore. When that latent heat is not released, means there is nothing strengthening the low pressure. All that rainfall which is being received further will cool down the area. The low pressure will die out. And within a couple of days, this entire cyclone will fizzle out, will dissipate. So that is about the entire process and the concept of formation, dissipation, and development of a tropical cyclone. Once you understand this concept, you will never need to revise it again because this concept is driven by logic. You don't need to learn anything here. Purely by logic, if you look at it, that how various different regions will behave under different conditions, you will get your answer here. So this is a much clearer image, the image that you will find in many of the cases. So observe, here you will have that low pressure, and that low pressure basically will end up bringing that entire cyclone. Now this region will have very strong winds. The winds oftentimes are able to carry some amount of surface water along with them. That is why in many of the cases, you will observe that at the region of the low pressure, sometimes you will experience that the water level is ever so slightly elevated. And as then this low pressure travels and hits the ground surface, all that accumulated water hits the ground surface, and you have coastal flooding, which is also referred to as a storm surge. So, this is the cyclone. This is where we refer to it as the eye of the cyclone. Sinking air, higher temperature, no cloud formation, clear sky. And on the sides, it is here that the clouds will be very dense and thick, and this is your eye wall. This is your eye wall. Okay. So when you have these very strong winds which are moving, oftentimes they bring about the water, the elevated water along with it, the elevated level of water along with it, and that will flood the region, coastal areas. It is because when you have very strong winds, they are able to drag some amount of surface water along with them, and that is when they will flood the coastal areas. Now, this is what is referred to as a storm surge. That is a surge in water level initiated because of very fast wind movement. That is what is referred to as a storm surge. Okay? So I hope that is understood. Ashwant, does the sinking of air in the tropical cyclone suppresses the cloud formation in the eye? Yes. Low pressure is also low at land surface. Lakshmi, not always the case, but in this case, please understand continuously you have a lot of rainfall being received also, and thermal low pressure, it will get impacted when you have a lot of rainfall and cooling, which is caused as a process of that. Okay. And then won't sinking air lead to high pressure? Sinking air in this case will increase the temperature around that region of low pressure. So, around it, as the air is sinking, it will increase the temperature of that entire region. And in that region, the temperature is so high, it will attract the winds to rise in a spiral manner around that central sinking portion. Please understand that sinking air is not very powerful. That sinking air is basically weaker sinking air, enough to increase the temperature, and it is induced only because of the rising spiral. Had the rising spiral not been there, that is not a region of sinking air. Kishan, you have a question that westerlies is as strong as they can initiate the movement of cyclone. No, westerlies, they cannot initiate the. Okay, you are talking about the general movement of temperate cyclone. Yes, they can always end up influencing that. And if westerlies is as strong, then blizzard affecting northern parts of North. Blizzard, my dear friend, is a very different phenomena. It is purely initiated by the increased cooling of the land masses in the polar areas or the cooling of the polar regions. That is why blizzard is initiated. And it is not as if that where blizzard is there, westerlies will also always be there. These trade winds and the westerlies and etc. that we have talked about, we have seen that how they exist in zones. But nonetheless, why are you relating both of them? Both of them are very different phenomena. Blizzard is the cold wind coming from the north, right, carrying powdered dust or powdered snow, etc., lowering the temperature. It influences the northern portion of Siberia, northern portion of Canada, etc. Okay. Okay, I'm trying to take as many questions as possible. Please don't have grievances in between. Storm surge is basically when the strong winds, they will attract the, or they will carry the water due to the frictional drag, they will drop it on the land. That is what is storm surge. The waves which are created by the wind movement. So when you have very strong winds, they will try to drag water significantly more, and that is what will increase the water level, which is referred to as a storm surge. Yes, Samarjit. And Shalu, how latent heat intensify the low pressure? Latent heat will increase the temperature in the central portion, and that central portion's temperature, when it is increased in this entire area, it will heat up that region of low pressure on the surface as well. And this is a thermal low pressure, hence it will get more intensified. Uh, does IMD make accurate prediction? Yes. Low pressure on land mostly leads to hailstorm and cloudburst instead of cyclone. It can cause rainfall, cyclonic rainfall as it is referred to in certain areas, but not a full-fledged development of a tropical cyclone. Never. Uh, What causes latent heat? Whenever you have a change of state from one state of matter to the other, late heat is either absorbed or released during that change of state. That is what we have as the latent heat. Here you have vapor which is getting converted into liquid, and hence you have that change of state. Can we draw the diagram that you draw in answer writing? Absolutely, yes. This is the diagram that you should draw. Yes, Shalu, that is correct. And Deepika, I've answered. Anthony, what actually causes latent heat is the energy, Anthony, for the change of state that is required. And Madhur, in heat engine, you didn't mention about formation of cloud. I talked about condensation here. Condensation here, when it happens, that is where you have the formation of clouds, isn't it? The condensation is in the form of clouds. How else will the condensation happen? How low pressure intensified in case of temperate cyclone? Low pressure is not intensified in the same extent. The low pressure develops or matures because as the cold and the warm front they materialize in that entire region, you will observe the rise of warm air. And that rise of warm air, when it is happening on a large scale, whenever you have a rising air, that will induce low pressure. So whenever on a large scale you have the rising warm air, it will induce a low pressure. Okay. Spiral movement is initiated Pravalika due to the Coriolis force. Okay. Sudden intensification of low pressure in the bomb cyclone can get created, or that sudden intensification can happen because sometimes it might happen that suddenly you have a strong whiff of wind movement, means stronger rise of air, and that means intensification of low pressure. Sometimes it can also happen that a region where you have a low pressure that gets additional heat as well because of other conditions of temperature and insulation, so that will bring the thermal factors into the play as well. So that can also lead to intensification. When you have a greater difference in temperature between the colder and the warmer air, that also creates a very distinct air front which is created, and the gradient also is very distinct, which can also initiate the intensification of low pressure. Tara, yeah, please ask your question. I'm unable to take a look at your question. It is not visible. And Anthony, is latent heat caused by the spiral wind or condensation? Condensation, my dear friend. And Pratibha, you said that there is no Coriolis force as it is near equator. Pratibha, I had said that at equator there is no Coriolis force. That is why tropical cyclones won't be formed at equator. Tropical cyclones will be formed in the tropics other than the equator, because at equator you don't have the Coriolis force. Nirbhay, can we skip geography? Absolutely, yes, my dear friend. You can. You only have 16 questions being asked in the prelims examination, and around 105 marks of it asked in the mains examination. Absolutely, you can skip it. And you can write in the answer sheet that ask me questions that I know about. Ask me about IPL, ask me about the Masala News, and they will always oblige. Then temperate cyclones induces through fronts, and tropical cyclones through Coriolis force. Am I correct? No, you are not correct. Temperate cyclones are induced due to fronts. Tropical cyclones are induced due to thermal low pressure. So that is why the tropical cyclones are created. Okay. Eye wall is the region where all that condensation is happening. That is why it is in the eye wall where you will find the thick clouds which are getting created. That is where you will find the presence in the eye wall. Sinking air in this case will not lead to high pressure. No. The same question you are pasting again and again. Why cyclone moves to why cyclone moves towards land? That is influenced by the movement of the wind in general. Please don't paste the same questions again and again, my dear friends. Below it, there is a cold front. So, what happened? Cold front does not mean that there won't be low pressure. Please understand, pressure is not always determined by temperature. When you are talking about pressure, I have been repeating this since past 3 to 4 classes. Pressure is a factor of temperature as well as the movement of the air. So if you have a cold front underneath, and if in that region warm air is rising up at an increased rate, on the ground surface, you will experience a low pressure always. How the downflowing air is getting compressed, because as it is getting pushed down, it is basically getting reduced in volume, and that is how it is getting compressed. The sinking air in the tropical cyclone Ashwant is generated because all around it, the air is rising up in a spiral manner in the central portion. That creates a kind of a suction which pulls the air downwards. Yatindra, from low pressure area, air diverges in the tropopause. Yes, almost. Air sinking in the eye, is it surface wind that moves from high pressure or the tropopause? The tropopause air movement, my dear friend, it is upper air. High pressure will never have cloud formation, Harshita. Never will you come across a high pressure leading to a cloud formation ever. Can warm ocean current cause bomb cyclone? Yes, significantly. Yes, Bhavna, that is correct. Tara, your question is, when low pressure on the surface of water, then it raises of air and temperature, how increase? I'm unable to make sense of the question, Tara. If low pressure, when low pressure on the surface of water, then it raises of air and temperature, how increase, sir? Okay, whatever I have tried to understand is basically, the question is, when low pressure on the surface, so why is that low pressure on the surface of water? That low pressure is on the surface of water because of heating, because the temperature of the water has increased. So when the temperature of water has increased, that will create the low pressure. When that will create the low pressure, it will attract winds from all directions, right? When the winds come here, they will get heated up by that low pressure. Why? Because that low pressure is due to the temperature factor. So the air gets heated up, air will rise up. Air will rise up in a spiral manner because of the Coriolis force, right? So that is why the air rises up. After touching land, cyclone continues for maybe 3 to 4 days. Nirbhay, it is very tough, not able to understand anything. So, see, I won't issue any kind of comment here. That is mostly because of lack of revision in many of the cases. Many of us are not in the habit of revising, and in many of the cases, I also see that in between a couple of classes are missed, and then after that, again, we make a comeback after 3 classes, and we expect it to behave, the subject of geography to behave just like the subject of history or polity, where what will happen if I miss 1904? Even if I attend from 1930 onwards, I will at least understand what is civil disobedience, what is Gandhiji that was doing, what is it that was happening where, around Simon Commission, etc. Geography is not a subject like that. I had told it and I had said it in the class from day one. Each of the concepts we start from the basic, but if you happen to miss out on an important chunk, you require to cover it in order to understand that. Okay, so that is where it is different. Geostrophic wind is basically, Shashank, a wind which moves parallel to the latitudes. So it is generally observed in higher elevations. We will study jet streams, which is an example of geostrophic winds. Okay, why bomb cyclone more in temperate areas than in tropical regions? It happens in tropical regions also sometimes, but tropical regions naturally they have a tendency to intensify themselves. Temperate cyclones they do not. So that is when Certain conditions are required for the sudden intensification, as pointed out, including the warm ocean currents. That is why. Okay. How the release of latent heat causes the air to sink. Release of latent heat doesn't cause the air to sink. You have the circular motion of the air, circular rising motion of the air, which causes the central portion to sink. That is what I had told you with the bucket and water example, that as you move in a kind of a vortex, the central portion immediately sinks. Okay. Is it correct? Tropical cyclone form on the seas. I will give you the difference between the tropical and the temperate cyclone. Don't worry. Is it possible for multiple cyclones simultaneously at a gap of small distance? At some distance, it can develop. Yes, it does happen. What is also referred to as the Fujiwara effect. Now, again, this was pertinent in the portion of current affairs, not relevant for your portion of GS geography. Fujiwara effect is when you have two cyclones which are formed in very close quarters. Oftentimes, they end up rotating around each other and they will merge. They can form a very large cyclone or they can dissipate also. Okay. Bhavna, that is the question that I just now answered. Bomb cyclones prominent in temperate cyclones more because tropical cyclones naturally will intensify themselves. Temperate cyclones over a period of time, they are at a moderate level. That is why when the sudden intensification happens, we refer to it as a bomb cyclone. Can tropical cyclones keep the water can tropical cyclones can keep the water up? Water won't rise in a spiral manner. There will be, because of that low pressure, water will have a slight rise, but that is it. Okay. So now we take a break, guys. We take a break for 10 minutes and we come back. So we take a break, come back at 8:10. Okay. A confirmation about the audio, please. If the audio is clear and available. Good. Ashish, my dear friend, please ask a question. I'm unable to take a look at the question, so that is why I have not replied. See, I have tried to take up as many questions as possible. Okay. So, Shreyank, why does eye attract wind from the upper atmosphere? Because in the region of the eye, you have a rising air column in a spiral that provides a kind of a suction in the center, and that attracts the winds downwards. Is people saw circular movement of winds as it spreads over a area? No, people won't be able to observe this circular movement because this entire spread of the cyclone that happens over a span of around 500 kilometers. So that is why it doesn't take place. Role of the latent heat basically is that when you have latent heat, that basically provides heating in the central portion, and that exaggerates the heat of the low pressure, intensifying the low pressure. Fronts and the types of fronts. So you have the fronts are where you have a difference in terms of the properties of the air parcel. Wherever you have the air parcels which are meeting the zone of transition having a different property, that is what is referred to as a front. The different types of fronts we have discussed in detail in last class. Kindly take a look at the recording. Whichever portion is not clear, feel free to ask after that. I will come to the question. Okay, I see the questions that you are typing. There is no need to kindly repeat the typing portion and copy and paste that. You guys are so very specialized in doing that. Please understand what it does is, so your question is only predominant always, the other questions are hidden. So please, let's not be so selfish. And so question about color coding, I will come to it, Kishan. Have patience. And Lakshmi, playas in geomorphology, they are created as a result of the wind action. And that wind action basically ends up creating a depressed area. That is depressed area generally at the foothills of the mountains. That is what is referred to as playa. Many of the times it collects the seasonal water from the surrounding streams and runoff, and that forms a saline playa lake. Okay. And Ravindra, difference between cyclonic rainfall and tropical cyclone. Cyclonic rainfall is when you have a low pressure center on the land that brings about air from surrounding, and that brings about rainfall. That is a cyclonic rainfall oftentimes. And when you have the development of a cyclone, it is a full blown development of that low pressure and intensification of that low pressure. How clouds moving away cut heat supply. Let's suppose if the wind in the upper atmosphere, Raghav, is very strong, it will drain away the clouds. So in that region, there will no longer be availability of latent heat of condensation in the central portion. So intensification of low pressure will not happen. Okay. So that is the case of the formation of a tropical cyclone. Very quickly, let me recap the entire process so that it cements in your mind. So this happens because of intense heating of the ground area, of the water bodies. Intense heating that sometimes you might experience the temperature of the water body to increase to a level of maybe 30-32 degrees Celsius. So you have very intense thermal low pressure created, which attracts winds from all directions. These winds, they bring moisture along with them. They rise up, and as they rise up, they undergo condensation. Condensation will bring in the latent heat of condensation in the central portion. That latent heat of condensation will further exaggerate the rate of the low pressure which is present in the center. And that is how you do observe, or you do come across the scenario of intensification of low pressure means more winds will be attracted, means more air will rise up in a spiral manner. Now as the winds, they rise up in a spiral manner, in the central portion they will create a suction force. Imagine it in a very similar analogy. For example, let's suppose when you have a bucket of water, you provide it a whirl around the corners, around the edges. You will observe that around the edges, when you have rising water, in the central portion you have the sinking air, sinking water which is present. A similar fluid dynamics is operated by the air also, where all around it, as the air continues to rise up, in the central portion the air sinks, creating that adiabatic compression and further heating of that low pressure. It basically, the cyclone dissipates when it hits the land, because then its supply to moisture gets cut off. Okay. Do moisture release heat during condensation? Yes, my dear friend. Why there is a shift in the eye of the cyclone? With the help of the movement of the winds, that is why you have the shift in the entire cyclonic process. uh, right. And okay, so after this, we come to the portion of the naming of the cyclones. Before that, when the cyclone alert is issued by the meteorological department, the cyclone basically can have different wind speed. Depending upon the intensity of the low pressure, the cyclone can have varying strengths. If, let's say, the low pressure is particularly strong, the cyclonic winds will be much more stronger, the devastation cost will be much higher as well. So that is why, greater the low pressure, more intense will be the development of that cyclone. Now, that means intensity of low pressure, if it is predicted, the cyclone warning is issued. And when the cyclone warning is issued, you have various different color codation which is provided for that warning system. You have the color codes in the form of green, orange, yellow, and red. So obviously, green means everything is fine, everything is okay, no need to worry significantly. It is going to be a weak wind which is going to blow over, and cyclone is not going to make much of a damage. Orange means that after or it will have very strong wind, it will have greater amount of rainfall, but the destruction caused won't be devastating. Yellow basically ends up meaning that the damage caused can be significant, because the wind speeds are going to increase. And then the red classification means that after landfall, it has got the capacity to induce a lot of damage, a lot of devastation. So that is the color codation based upon the strength of the cyclones that we experience. And yes, that depends on the intensification of low pressure. We can't stop the cyclone from its initial formation, no, because these are very large processes, you cannot stop them. So now we come to the factor of naming of cyclones. How is it done? Why is it done? Now, cyclones were not always provided with a distinct name. Earlier, the naming would be done, but it would be done in a very kind of a scientific process, where certain alphabets and certain numbers would be associated and attached to the cyclone, only for scientific reference purposes. But then something happened in 1999 which changed it all. The experience that we gained in 1999 brought about a newer methodology to deal with cyclones. And in 1999, the event happened in the coastline of Odisha. All of you belonging from Odisha, you would be very, very young at that point of time to have experienced these cyclones. But if you ask your elders, the older generation, they will always give you stories about what 1999 did to Odisha. So in 1999, as per the prediction, as per the estimation, there was an estimate that a significant low pressure, a very intense low pressure, is being developed, and a super cyclone. So, cyclones are also classified based on the intensity of low pressure into weak depression, low pressure, intense cyclone, and then you have severe cyclone, and then you have super cyclone. Super cyclones are the ones where the wind speed exceeds to 20 kilometer per hour. Severe cyclones basically are where the wind speed is roughly around 200, 180 to 200 kilometer per hour. Now, basically, in 1999, there was a prediction that a cyclone, possibly a super cyclone, is going to hit the coastline of Odisha. And at that point of time, our disaster management system was not even set up. So we had no standard operating procedure that what to do when a disaster strikes. Now, in present day scenario, if let's say the government tells you and there is a notification from the central government that, okay, this is something that you should not do. On this day, you should try not to come out of your house. You will find that many of us, we have the urgency and the urge within ourselves. Let's see what happens. Let's see, let's try to come out of our house. Let's see what the government order is about. So there has always been a kind of a methodology of defiance in terms of these government orders. Now, in 1999, the central government issued a warning and basically encouraged people to evacuate their houses and their homes and move to safer places because a cyclone is going to strike. Now, again, imagine if in a rural area, some officials from the government come and they ask the people that vacate your house or a disaster is going to impact you. How will the people respond? They will always respond with a significant degree of suspicion that maybe they are here to grab my land, to grab my household items. So people, they don't always respond positively to evacuation issues. Now, few of them evacuated. Many of them did not. And the government's messaging was also very inefficient at that point of time. In today's day of media and everything, it is very hard to imagine a circumstance where government issues an emergency warning and people don't take heed of it. But at that point of time, we are talking about 1999. So obviously, it was inefficient. The cyclone struck. People did not evacuate. People had not evacuated. And a cyclone struck, brought about very heavy wind speed, close to around 220 to 30 kilometer per hour, coastal flooding, storm surges, all the destruction and devastation that you can possibly think about. Now, when this happens, you cannot be angry on the nature, can you? Whenever a natural disaster happens, have you seen people getting angry on the fact that, you know what, this time Bay of Bengal has basically betrayed us. Bay of Bengal never gets heated to this extent and it has created that cyclone. The cloud formation has betrayed us. No. Anger is never vented out on the natural forces. Anger is vented out on whom? On the government. That you are responsible. You did not tell us that this scale of cyclone will come. The government on its side said that, look, we had tried to convey the message to you, but people did not evacuate. But obviously, anger, when at the face of loss, is very exponential. So people were very angry. Now, people were at that point of time involved in collection of the materials which have been wasted, searching for the lost ones, the near and the dear ones. They were involved in that. And within a couple of days, the meteorological department actually detected that there is another cyclone which is developing in the region of Bay of Bengal and which can hit Odisha coastline again with very high amount of intensity. It will not be a super cyclone, but it can come into the category of a severe cyclone. So then this time, government left no stone unturned. And the government started announcing it that, you know what, a cyclone is going to strike, so kindly take shelter. Now, when this happened, people, the first impression that they got is that, look at their efficiency. The cyclone has come, destroyed our lives, and now they are bringing up that announcement. So this is the delayed government machinery as always. And people basically did not pay attention to that. Few of them, few of the people, they did manage to this time finally evacuate their houses, but many of them, they were out in the open looking for their loved ones, looking to recuperate their lives, get their lives back together. And that is when the second cyclone struck Odisha. The second cyclone hit it within 10 days of the previous one. And this time, a lot of lives were lost, a lot of properties were also lost, because this time it caught the people unawares. Many people were out in the open. Now, in within these 10 to 12 days, It is estimated close to around 10,000 to 15,000 people, they lost their lives. The entire coastal area from Puri all the way around till Cuttack, Bhubaneswar, every region was devastated, destroyed by the cyclone. Habitations were no longer identifiable because that much amount of destruction had happened. And why did this happen? Because people did not understand that a new cyclone is coming. So, from this, a learning was gained. A learning was gained was the fact that why don't we name these cyclones? Let us name these cyclones. So that is when 8 countries around the northern Indian Ocean, they got together, and they all of them they submitted 8 names. So you had in total 64 names which were submitted, and the naming process began since 2001 onwards. When a cyclone would occur in Bay of Bengal, a name would be picked off the list and the cyclone would be named. A cyclone occurring in Arabian Sea, a name would be picked off from the list and the cyclone would be named. Now, the last name on that list was the name of Ampan. And in April, late April and early May of 2020 was when the super cyclone Ampan that struck West Bengal coastline and eventually dissipated by the time it reached Bangladesh. So, much before that last name was being allocated to a cyclone, people did realize that this naming list is coming to an end. So, all these 8 countries they got together, but this time we had 5 more new countries which came to that particular table. And now we had 13 countries in the northern Indian Ocean, all of them getting impacted by the cyclonic developments either in Bay of Bengal or Arabian Sea. All of them they got together, and all these 13 countries they submitted a list of 13 names, and that is how initially you had the entire framing of that list. Now, 13 countries giving 13 names means in total how many names do you have? You have 169 names. So one by one the naming is done, whether a cyclone is occurring in the region of Bay of Bengal or Arabian Sea. One by one the naming is done. So what happens and what is the process is actually the Tropical Cyclone Warning Center, that is TCWC, that issues a warning that look, a low pressure is developing into a cyclone. Not all low pressure will develop into a cyclone. But when a low pressure starts developing into a cyclone, the Tropical Cyclone Warning Center issues a warning. And that warning is received by the regional specialized meteorological centers. This RSMC, you have various RSMCs across the world. If you will observe across the world, you have around 6 RSMCs which are present. You have the RSMC in Miami, Florida. You have RSMC in Honolulu, RSMC in Nadi, RSMC in Tokyo, RSMC in Reunion Islands, which is governed by the French Meteorological Department. And then you have RSMC in New Delhi, which takes care of the naming of the cyclones happening in northern Indian Ocean. So when RSMC New Delhi receives that warning from the Tropical Cyclone Warning Center, it picks the name of that list and it provides that list. So basically, how is the list arranged? So here you will find the 13 countries which are present. They are arranged in alphabetical order. Bangladesh, India, Iran, Maldives, Myanmar, Oman, Pakistan, Qatar, Saudi Arabia, Sri Lanka, Thailand, UAE, and Yemen. All of these bordering the region of northern Indian Ocean. Now, each of them, they have given a list of 13 names which are arranged in rows in front of them. And you have 13 columns by created by these names. Now, one by one, what is done is that a name is picked off from the list. The next cyclone which will occur, the whether in Bay of Bengal or Arabian Sea, a name will be picked up from that list. So here, if you observe the last cyclone before Mocha, which occurred, before that you had Mandus, before that you had Sitrang, right? Now the cyclone which has occurred has been named as Mocha. The next cyclone which will occur, regardless of whether it occurs in Bay of Bengal or Arabian Sea, it will be referred to as Biparjoy. After that, the cyclone which will occur, whether it occurs in Arabian Sea or Bay of Bengal, it will be named as Tej. After that, the cyclone which will occur, whether in Arabian Sea or Bay of Bengal, it will be named as Hamoon. After that, the cyclone will be named as Midili. So that is how one by one you will have the entire naming of the cyclones for all the 169 names. And eventually, after that, once that name is basically about to end, that is when a new naming list will be finalized and the naming process continues. When we talk about regions such as North America, due to factors of climate change and oceanic circulation, the region of Atlantic is experiencing very high frequency of hurricanes or cyclones occurring. That is why last year you had a very unique scenario where RSMC Miami, it simply ran out of names when it comes to the naming of the cyclones. And that is when it started naming the hurricanes based upon the Greek alphabets. So you had Hurricane Alpha, Hurricane Beta, Hurricane Gamma, Hurricane Delta. That is how the naming was done. Naming is done for the prime factor in order to have a different identification of a cyclone so that people can associate with it. People don't refer it as a simple cyclone. What cyclone is coming? So if this would have been present in Odisha at that point of time, maybe thousands of lives could have been saved. But it is because of these events that a lot of learning was taken. And eventually, that is why in today's day and age, you will find that Odisha has one of the most efficient disaster relief forces across the country. They have an absolute meticulous plan of deployment, absolute meticulous plan of how to carry out the process of rescue and so on. So in the present list, how many names are there? You have 13 countries giving 13 names. Multiply it, polish your CSAT, you will get an idea about how many total names. Okay? So that is basically the impact of these cyclones. Right? Now, this is the difference between a list of difference between tropical and temperate cyclone. When you talk about tropical cyclones, they generally move from east to west. Why? Why is it that the general motion will be from east to west? Because they are impacted by trade winds, movement of trade winds. And the temperate ones, they move from west to east because they are influenced by westerlies. A tropical cyclone has an effect on a comparatively smaller area, but the velocity is much higher, causing a lot more damage. And it forms only on seas, whereas temperate cyclone can get created either on sea or on a land area. Tropical cyclone doesn't last for more than 7 days, whereas a temperate cyclone can last for 15 to 20 days on a stretch. Okay, so that is the difference here. And here also, there is an impact of the trade winds and the motion, but these cyclones, they also get impacted by the Coriolis force. So for suppose a cyclone develops, let's suppose that you have the development of a cyclone across the coastal area here. Now, if the cyclone's motion as induced by the trade winds, let's suppose, is here, due to the Coriolis effect, the cyclone will start to curve to the rightward direction. That is why the Mocha cyclone, which developed over the region of Bay of Bengal, that Mocha eventually curved right, bended right, and went where? It went to Myanmar, right? It went to Myanmar and it hit Myanmar coastline, causing destruction there. So that is why sometimes, let's say the cyclone's path is to be like this, it will recurve and it will hit, let's say, Odisha coastline, induced completely because of the Coriolis effect. So that is how the motion of the cyclone takes place. Now that brings us to the overall summarization, the summation of the entire process of air masses and their impact that is experienced on the climate. So whenever you have the air masses will have an influence on the temperature of a region. Always. How? By the process of advection. Of advection. Then, when we talk about precipitation, whenever you have a moist or a maritime air mass, when it hits the land, it will bring rainfall always. So, moist or maritime air mass cause rainfall. Then, when we talk about the impact of the air masses, they also induce the formation of the fronts. They lead to the creation of different fronts, and each of the fronts will have their own independent weather condition associated with it. We have seen that warm front will have its own independent impact. Cold front also has got its own independent impact. And then these air masses, the mixing of them, can also bring about cyclonic events, temperate cyclone, tropical cyclone, etc. So, if a question is asked about the influence and the impact of air masses on the climate, you can write, I hope, a detailed 250 word answer can be written by elaborating upon each of these facts, that why it happens, where it happens, what are the weather conditions that are associated with it. Okay, so that is basically where the we end the portion of cyclones. Okay, what you see here as prawns, Shashank, this is pronunciation. This is nothing but pronunciation. That what is the pronunciation of the name? For example, people can read this as mocha also, right? So that is where mocha. For example, observe this. On the name of it, it is referred to as Michang, but here you have the pronunciation Mikjom is the name of it. So it is basically each of the names are provided in their own regional language. That is why the pronunciation is associated. Okay. Now, the questions which are asked from this, from the portion here. So discuss the concept of air mass and explain its role in macroclimatic changes. So when you are answering this question here, think about it, that when you talk about the concept of an air mass, in the introduction, you have to write, what do we understand by an air mass? The definition that you see in the PPT, something similar to that, you can write that air having distinctive property of temperature, water vapor presence, moisture density, etc. That is an air mass. And role in climate changes, that is something we have given. Now, tropical cyclones are largely confined to South China Sea, Bay of Bengal, and Gulf of Mexico. This is an answer. This is a question I want you to hold on to yourself. We will answer this question when we complete the portion of oceanography, because the factors of ocean and ocean phenomena, that is also responsible for development of cyclones in certain areas. When we come to it, that is when you will be able to better answer it. Then recent cyclone on the east coast of India was called Phylin. This is basically a question which was asked probably in 2014 or 13. How are the tropical cyclones named across the world? So in this case, you have to talk about that how TCWC initiates a warning. Then what are these RSMCs? Where are they present in the world? RSMC then picks the name from the list. Where is it that the list is generated from? So the list basically is given by these member nations. So here you have to talk about the 13 member nations. They have provided the list, and one by one the names are picked up, and that is how the naming is done. Okay, please don't end up learning the names. Please never end up learning the names. That is the worst thing that you can do to yourself. If you have that much time, learn something else. Maybe learn a new hobby, but please don't learn the names of the cyclone. Bring out the causes for the formation of heat islands in the urban habitats of the world. So, causes for the formation of heat islands. This is the urban heat island. So here in the introduction, you have to first of all write about what do you understand by heat islands. So heat islands are those regions in the urban landscape where suddenly the temperature indicates a marked increase as compared to the surrounding region. So that zone of excessive heating is referred to as a heat island. And what are the causes for the formation? We have discussed in detail, so you can discuss those causes. Bring about an image in all of them. In all of these, diagrams are an essentiality. You cannot miss out on the diagrams. Please don't miss out on the diagrams. Talk about the causes of these urban heat island formation, a couple of sentences about each one of them, and that is sufficient. Then what do you understand by the phenomena of temperature inversion in meteorology? How does it affect the weather and the habitats of the place? So, discuss what is temperature inversion in the introduction very briefly. Then, in the body portion, when you start, elaborate further that what is the condition where in inversion you don't have mixing of air which happens anymore. So, what are the conditions it leads to? All of those factors you have to discuss. Types of temperature inversion and the influence on climatic condition, lack of mixing of air, etc. You can talk about it. Okay. So after this, we come to the portion of atmospheric phenomena. Now, just like in the case of temperate and tropical cyclone, here also let me tell you that this is a particular portion in special or in particular where you don't find it explained in the books. At least the phenomena that we are going to discuss and the detailing at which we are going to discuss, you won't find it in the books. So always pertinent for you or important for you to pay attention in the session, understand it, understand the basic process, that what they are, why they are initiated. Once that is done, your job is also done. So, how inversion influences weather? In many of the cases, it brings about a lack of weather condition. It prevents mixing of air. Fog development will happen. In the case of surface inversion, you have the radiation fog which develops. All these factors are in impact on weather, isn't it? I hope that is understood. Frontal inversion can end up creating significant amount of rainfall. You have significant rainfall in the cold front, warm front, different types of rainfall. That is again caused due to inversion. Valley inversion, when it is caused, the temperature conditions at the valley bottom will get excessively low, causing loss of life for the biodiversity. Right. So these things you can automatically write on your own. I'm sure about that. So now we come to the atmospheric phenomena. Here we shall be discussing few of the factors, such as, first of all, we shall be discussing what do we understand by Walker circulation. Then we shall be discussing the Enzo cycles. That is El Nino, La Nina, La Nina. What are they? Then after that, we shall be studying about Indian Ocean Dipole. Then after that, we shall be looking into Madden-Julian oscillation. Then after that, we shall be moving ahead into the portion of jet streams. Okay. So these are the areas that we are going to discuss. Now, these are atmospheric phenomena which are prevalent across the globe. So they end up influencing the global climate, and world's climatic conditions are impacted by this. But why do we study this? We study this because it ends up impacting the Indian monsoons as well. And monsoons for India is very, very essential for not only the survivability, but also the growth prospect of the country. You would have observed that yesterday, when the growth data was released for the Indian economy, or the GDP growth data was released, you had a warning which was issued that this year is an year of El Nino. So we are going to have a problem in the case of the monsoon. So that is why, because the monsoon is impacted by all of that, that is why we will study or cover these portions. Now, out of these, in general, all these things that you see, these are going to be relevant for your prelims, all of them, where a basic level of understanding is basically asked by the examination and by UPSC. That are you aware about what is happening during El Nino? Are you aware that what is it that we refer to as Indian Ocean Dipole? Those basic levels. In the mains exam, you get questions from the portion of sometimes even Walker circulation and also questions from jet streams. They are also asked. Okay. These are the questions that you come across in the mains examination, whereas in the prelims, but I'm sure right now, because just now the prelims have ended, everybody is only concerned about prelims in their life. Nobody is even thinking about mains exam as of now. So basically, in the prelims, all of these are important to be aware of. Now, we start with the very basics of it, and we start with the Walker circulation. But before the Walker circulation that we discuss, very quickly brushing up the basics. Now, we have seen that wherever there is heating, right, wherever there is heating, there is a rise of air in that region. Rise of air always induces a condition of low pressure. Low pressure is associated with formation of clouds. The air rises up. It hits the region of tropopause. It then diverges and then eventually will sink somewhere. And wherever it is sinking, it will create the conditions of high pressure. High pressure means lack of rainfall, right? Clear skies. That is what you experience in the case of high pressure condition, isn't it? But till now, what is it that we have experienced is basically that if you think about the planet, till now, what is it that we have experienced? We have experienced that air rises up at one latitude, sinks at another latitude, circulates, rises up or moves here, rises up at another latitude, sinks in at another latitude. So we have seen a kind of a latitudinal motion of air. That air rises up at one particular latitude, sinks at another latitude. It ends up creating a kind of an effect whereby we see what? We see that between the latitudes, rise and fall of air parcel takes place. But you had a very great climatologist of his own time, Sir Gilbert Walker. And those of you who are offended by the term sir, please ignore that. You can uh, talk about that person, individual, as Gilbert, Gilly, Walker, whatever you want to call that person, you can call. But his name was referred to as Sir Gilbert Walker. Now, Sir Gilbert Walker was an acclaimed climatologist of his times, very acclaimed climatologist of his time. in the late 1800s. Now, Gilbert Walker was absolutely convinced that this rise and fall of air can never be restricted only between the different latitudes. This rise and fall of air can happen within the same latitude also. Why? Because he was convinced that look, temperature is not dependent on only one factor. Temperature is dependent on multitude of factors taken together. So it can absolutely happen that a particular region across the same latitude gains a different temperature as compared to the other region across the same latitude. He was absolutely convinced about that. And that is where he thought that Pacific Ocean is the ideal case in point. Pacific Ocean is so very wide that in the region of the Pacific Ocean, he was convinced that one region might get much warmer as compared to the other area. So that is where he came across with his own Walker circulation. What that circulation was, we'll come to it. But then, before that, when he was convinced about this particular circulation happening, he was also convinced that the temperature heating and cooling of the Pacific will have some impact on the Indian monsoon also. That is when he decided to come over to India. And when he decided to come over to India, he basically started working in the Indian Meteorological Department, which at a later point of time he also became the head of. And he was working with the Indian Meteorological Department in the early 1900s. You would have studied during that time that the administrative effort was somewhere else about the partition of Bengal, Swadeshi movement, etc. I'm sure you would have studied. It was during that point of time when Gilbert Walker, he was in charge of the Indian Meteorological Department. Now, as the fate would have it, when he was in charge of Indian Meteorological Department, he could not sum up any conclusive study or any conclusive evidence. But when he later went away from India, then suddenly few of the researches were published, but eventually the understanding about Walker circulation increased almost around 50, 60 years later. Now, before trying to understand what do we understand or what is meant by this Walker circulation, why is it initiated, a couple of basic factors here. So when we talk about, let's say, the planet. Now we know that Pacific Ocean is the largest ocean in the world. I hope we know that by this point of time in our lives. I hope we know that particular fact. Now, around the region of equator, which is the permanent wind system which is in existence, around the region of equator, the permanent wind system in existence is the trade winds. And what is the direction of the trade winds? Trade winds move in this direction, isn't it? Trade winds move in this particular direction. Now, whenever you have a large water body and a wind is moving over it, what will be the speed of the wind? The speed of the wind will be generally higher, isn't it? Why? Because the frictional force is almost negligible. And when the wind speed is very high, it will be able to carry some amount of surface water along with it, isn't it? Some amount of surface water will be carried along with it. Now let us understand the temperature factors here. So when we talk about large oceans or seas, what is the source of heating for these large oceans and seas? What is the source of heat? It is the sun, the solar insolation. That is the source of heat for these water bodies. The heat provided by the sun and the solar insolation. So here, if the heat is provided by the sun and that is a major supplier of heat, we can also say that the surface water is going to be warmest at least in the region of equator, isn't it? That surface water is warmest and the subsurface water is comparatively cooler, isn't it? Now suppose here you have the subsurface water also. Now if there is a very strong wind which is moving, blowing against the surface, it will be able to drag some amount of surface water along with it, isn't it? It will be able to drag some amount of surface water. When that surface water is dragged away, what do you think will happen? Do you think in that region ocean will show a kind of a depression, like in the case of the wind landforms that we see? Do you think that ocean will indicate a depression, that surface water has been carried away from here? No. The subsurface water will rise up. So subsurface water will rise up and subsurface water is cooler in comparison. So when the surface water is being carried away, the subsurface water rises up, replaces that, and now you have cold water conditions. And cold water is associated with high pressure. Warmer water is associated with low pressure. So with these basics, let us now understand the basics of Walker circulation. So when we talk about Walker circulation, first things first, draw the equator here. This is where the equator, let's suppose, is. Now Pacific is very, very vast, very, very wide. So in the region of Pacific, you will have the prevalence of trade winds, isn't it? Trade winds, they move in this direction in general. They will be moving in this direction in general. Now, if I were to look at the movement of these trade winds only in the region of equator, let's suppose, only at the region of equator, if I were to look at the movement of these trade winds, what is the direction of movement that I can associate here? Can I say direction of movement in general is from east to west? I can say that the general direction of movement of the winds is from east to west. Now this wind is moving from east to west and it is moving over very large water body. The speed will accelerate. The speed will become very, very fast. And when it becomes very fast, it accelerates. What do you think will happen? It will be able to drag some amount of surface water along with it, isn't it? Surface water will be dragged. Now that surface water is the warmest portion of the ocean, at least in the equatorial and the tropical regions. Surface water is the warmest portion. Now that warm water is being dragged by these winds. And that warm water overall is accumulated here. In the western part of the Pacific, you have accumulation of that warm water. Now, as the surface water is being dragged away, in this portion around eastern Pacific, will we observe the lower portions of water to come up? We will observe that. Lower levels of water are slightly colder, isn't it? So here now, we have the presence of colder water, which have been uplifted from the lower portion because the surface water has been carried away, right? So here you have warm water, here you have cold water from subsurface. Here you have accumulation of surface water. Surface warm waters, they accumulate here. Now, in the region where you have the accumulated warm water, there will be a higher temperature. Now, as there is higher temperature, here you will observe a development of low pressure. And here, because you have colder water, you will come across a subsequent development of high pressure also. Isn't it? So you have what? You have attained a pressure gradient. That pressure gradient means the winds will have a stronger motion. Which wind? The wind that you find in this region, the trade winds that are present, they will get stronger. These winds will rush in towards that low pressure. As these winds rush in towards that low pressure, they will be carrying significant amount of surface water along with them. And all of that surface water will get accumulated in the region of the Western Pacific. Across the coastline of North Australia, all this will start getting accumulated. Now here, this will attract winds from other directions also. Now the winds, after reaching here, the winds will begin to rise. It is at the equator, so no Coriolis force here. The winds will begin to rise. As the winds begin to rise, they will form very dense clouds, isn't it? Very dense convective clouds will be formed. Very heavy amount of rainfall is observed in the region of northern Australia, Indonesia, Philippines. Very heavy amount of rainfall is observed. The wind rises further up. As it rises further up, it will diverge at the region of tropopause. And then one portion goes here. Around the region of that high pressure, there will be sinking. And then again, a kind of a recirculation. So this is a circulation that you have observed, whereby we have seen that it is not between the different latitudes, it is at the same latitude. But significant and substantial difference of temperature has been achieved. Why? Because of the wind movement. Wind movement which is happening has induced that kind of low pressure and high pressure condition. So this is different from our tricellular model of circulation, isn't it? It is happening at the same latitude. Hence, this is a different circulation. This is what is referred to as a Walker circulation. And this cell which is created, this is also referred to as a Walker cell. So overall, what happens in this region if you recap this? So observe here in this image, you have the trade winds which carry the warm surface water along with them. Observe that across the Australian coastline, that warm water starts to accumulate. There is a building up of the convective clouds around that low pressure, causing very heavy rainfall across the Australian coastline. Whereas near the Peruvian coastline, you observe fair weather. WX refers to weather, fair and dry weather conditions because of high pressure. And observe that the cold water is coming upwards as well. This is also what is referred to as upwelling. The portion where the cold water comes above, that is also what is referred to as upwelling. So here, the entire chronology. So trade winds generally blow from a general direction of east to west. Now, the winds blowing over the vast expanse of the Pacific gain a higher speed. As a result of that, these trade winds, they tend to drag some amount of surface water along with them. These surface waters are warmer due to the factor of solar insolation. As these warmer waters accumulate, that creates a condition of low pressure. and that induces a circulation at the same latitude, and that is what we refer to as Walker circulation. Okay, so that is what you have as the Walker circulation. So Walker circulation is the east to west circulation across the equatorial Pacific due to accumulation of warm water in the western Pacific and presence of colder subsurface water in the region of eastern Pacific. Is that understood? Yes, Swati. Walker circulation is observed across the region of equatorial Pacific. It will have an impact, a cascading impact across other oceans also. We'll take a look at it. But this is the basic of Walker circulation. If this basic is understood, El Nino, La Nina, etc., is simply a derivation of it. But this is basically a circulation initiated at the same latitude, because in one region you have accumulation of warmer water that induces a higher temperature area, means a low pressure region is activated, and meanwhile from the other region, as the surface water is being taken away, colder subsurface water is exposed, inducing the high pressure. Okay, now after this, very briefly, we talk about this is the Walker circulation. Observe here. So, Walker circulation here, you will observe warm waters get accumulated here in the region of the Western Pacific. So, here you will have winds coming from all direction. Okay, from all directions. It rises up, it diverges. This is the Walker circulation. And here you will have the sinking air inducing a kind of a high pressure in this region, right? So observe that it will have a cascading impact over the Indian and the Atlantic Ocean also. Okay, a cascading impact is observed here also. Now, here is where I want you to initiate the interlinking of the concepts. Okay, I understand it is very heavy altogether, but this is where I want you to apply your logic and start the process of interlinking the concepts. So if you take a look at this, basically around the region of Western Indian Ocean in general, the normal Walker circulation induces a kind of a sinking air. So in the region of the Western Indian Ocean, what pressure conditions do you think would be experienced here? A high pressure or a low pressure? What do you think? Why not water go beyond Australia? Because Elias, there is land there. Here you have land. How can water simply penetrate beyond Australia? That is why. So let me know. What do you think will be the pressure condition in the region of Western Indian Ocean? So that is where here we will have the conditions of high pressure. Why? Because you have sinking air. Now, for the formation of tropical cyclones, we require a pre-existing low pressure center to exist. Wherever you have a pre-existing low pressure center, that is where cyclones develop. So in these conditions of normal Walker circulation, you won't come across any tropical cyclone being formed over Arabian Sea. Whereas in this region, you might have development of cyclonic circulation because there is a pre-existing low pressure in that entire vicinity, and that might enter into Bay of Bengal. So that is the condition observed under natural circumstances, under normal circumstances. So that is why under normal circumstances, here is one of the factor why Bay of Bengal is more prone to formation of tropical cyclone as compared to the region of Arabian Sea. Now, why only east to west circulation? Why not vice versa? Vivek, what is the wind movement around the region of equator? You have the trade winds, and the trade winds move in which direction? East to west. That is why the water carried is in the western direction and the colder conditions are in the eastern direction. So high pressure to low pressure, you will have an east to west circulation which is initiated. Now, why Walker circulation is specific in the Pacific Ocean? Because Pacific Ocean is very, very wide. Pacific Ocean is very large, where the influence of the wind can be very substantial. Now, we come to the factor of upwelling and downwelling. What is it? So, here, if you understand, basically, if let's say we have the land area, let's suppose, and then you have a water body in between, let's assume. Let's assume this is a large ocean rather than a bathtub that it is looking like. So assume that it is a large ocean. Now, in this case, here, let's suppose we have very strong winds, offshore winds, very strong offshore winds. Now, these offshore winds, they will carry the surface water along with it. They will be carrying the surface water. As a result of that, what will happen? The subsurface colder water that will be exposed, that will come out to the surface, isn't it? So that rising up of the subsurface water, that is what is referred to as upwelling. Rising of the subsurface water, that is referred to as upwelling. Now, here, why? Because the surface water has been carried away by the wind. Now, suppose the wind is moving across the ocean, and eventually it is an onshore wind which is happening. So, what will happen in this case is they will drag the surface water, and that surface water eventually will accumulate and will be forced in this region. In this area, all that surface water will be forced down. So here, when you have the water which is being forced down on the coastline because of the wind action, because what do you think will happen? Will the wind be able to carry this water above land, bringing flooding to the land areas? Obviously not. So this wind, when it is moving, it will carry the water, it will carry it to the coastline, and then it will dump it there. That is where the wind that starts to sink down, and that is what is referred to as downwelling. So here, whenever you have upwelling, what happens to the surface temperature of water? Surface temperature of water, does it increase or does it decrease in the conditions of upwelling? It will decrease, isn't it? This will lead to a lowering of surface temperature. Yes, Ashwant, please take care of the health first. And then, Ritika, from tomorrow, will the class be at 9 a.m.? Why, my dear friend? Why will the class be at 9 a.m. from tomorrow? I'm interested to know the reason. Why do you think that from tomorrow classes will be from 9 a.m.? Is it a kind of a new rumor which has started, or is it something else? Please let me know where you are getting that. So don't, classes will be held on time. I'm surprised to find out and I'm curious to find out the source of information. Why you think that tomorrow classes will be from 9 a.m.? Is it because of the summer solstice or the summer timings, daylight saving? What do you think is the factor? So here you have lowering of temperature, and here due to downwelling, you will have accumulation of warm water which will then be pushed down, and here you will experience rise in temperature. Okay. right? Why tropical cyclone can't be observed in Arabian Sea? It can be observed in Arabian Sea. It is only in the case of this Walker circulation where you observe that in this region of Western Indian Ocean, you have sinking air, and that creates a high pressure condition. And for the formation of a tropical cyclone, you need a low pressure condition to be present. That is why here it will not encourage the formation of a tropical cyclone in Arabian Sea. Okay. So this is basically your factor of upwelling. So when the upwelling happens, you have the water from the lower regions which come up in order to replace the water which has been taken away from the surface. And due to that, many of the times, many nutrients from the lower regions of the ocean also come closer to the surface, giving rise to the growth of algal species like phytoplanktons. And these phytoplanktons, their number suddenly will start to increase because now the water from the lower regions are bringing them nutrients. And once the population of the phytoplanktons increase, the population of the fishes which are dependent on them, that also increases. So it is significantly helpful for the marine food chain in significant quantity. Tara, this upwelling and downwelling is not influenced by the land and sea breeze. This upwelling and downwelling, they are influenced basically by the onshore and offshore winds that are the planetary winds. So those winds are able to influence the upwelling and downwelling and not the land and the sea breeze. Okay. So here, high pressure on Arabian Sea, did it help monsoon? In a way, yes. So this is basically the definition of it. Winds blowing across the ocean surface push water away. Water then rises up from beneath the surface to replace the water that was pushed away. This process is known as upwelling. Upwelling occurs in the open ocean and along the coastal landscape. Whereas when we talk about the downwelling, also occurs when the wind causes surface water to build up along the coastline and the surface water eventually sinks. Right? Akula, they don't have a definite direction. Upwelling and downwelling can happen in different portions depending upon whether the wind is onshore or offshore. Offshore wind, that is wind moving away from the land, away from the coastal area, that will always be associated with upwelling. Onshore winds, that is associated with downwelling. Okay? That is the factor behind it. Okay. So very quick recap, I will give you about the Walker circulation before we finally enter into the Enzo cycles. So here in the region of equator, there is significant heating of the top portion of the water body. So you have the trade winds which generally move from east to west. And as these trade winds, they carry or they move across this vast ocean, their speed is very high because there is no resistance over the ocean. So they will be able to carry the warm surface water along with them. That warm surface water will accumulate in the region of the Western Pacific. Why don't they go into the region of Indian Ocean? Because here you have the land areas which are present. So in this region of low pressure, you have significant amount of rainfall which is caused. Meanwhile, as the surface water is taken away, subsurface waters, they expose themselves in eastern Pacific, creating high pressure conditions, causing drier region. That induces a circulation between high pressure and low pressure. That is the Walker cell or the Walker circulation. Now, after this, we come to the portion of Enzo, Enzo cycles or El Nino Southern Oscillation. Now, before getting into this portion, I want to understand few basic concepts from you. When we talk about the region of Southern Hemisphere, especially think about the Peruvian coastline, etc. During the month of December, what is the climatic condition that they experience? Summer or winter? Very good. It is summer that they experience, right? Now, we have seen that in normal conditions, you have the high pressure there. So the Peruvian coastline during the month of November, December, we have seen that it experiences summer. What will be the condition of rainfall? Will it receive rainfall or will it be dry under normal conditions? What do you think? Very good. It will be very dry because that is a condition of a high pressure. High pressure region will not receive rainfall. Right? Peruvian coastline is a high pressure region we have seen during Walker circulation. So it will be dry. It will be hot. It will be dry. Means conditions will be oppressive. Now, as the anecdotal story goes, it is during one of these December weeks, closer to Christmas. That is when few of the Peruvian fishermen who were venturing out into the sea, they experienced sudden onset of very heavy rainfall. Now, because it happened during the time of the Christmas, they thought about it, the occurrence of rainfall in December, they thought about it as a gift from Christ himself. And that is where that particular phenomena was referred to as El Nino or the Christ child. And that El Nino condition meant that rather than being dry and warm, Peru would receive rainfall during these months. Now, that is how El Nino started becoming prominent and very famous. Eventually, later on, the climatologists, when they investigated, they found out that yes, there is indeed a phenomena which brings about drier conditions or they bring about rainfall in Peru and drier conditions across Australia, Indonesia, and Philippines. They found out that this phenomena repeats itself every 3 to 4 years in general. And they named it as, again, El Nino as it was named. But upon carrying out subsequent research, they also came upon another fact. They came upon the fact that you also have a reverse condition in existence across equatorial Pacific. That the region of Peru will become extraordinarily dry and the region of Australian coastline, that is the Western Pacific, will end up receiving heaviest amount of rainfall. So it would be the reverse of El Nino. So they named it La Nina or the girl child. And they found it that this also repeats itself over a period of 2 to 3 years. So they found out that the conditions across the southern equatorial Pacific that changes between El Nino, La Nina, and normal condition or what was referred to as neutral condition. Okay. And here it was observed that every year or every few years, the conditions basically would change. They would change from neutral or normal to La Nina. They would come from La Nina maybe to El Nino, and these conditions would keep on changing. That is why it was referred to as the oscillation or Enzo oscillation, Enzo cycles, El Nino Southern Oscillation. The name Southern, why? Because happening in immediately the southern part, southern equatorial region. That is why it is Southern. And oscillation, why? Because it is happening either you have the conditions of El Nino or you have the conditions of La Nina which are in existence. That is why here you have either of them. Now, at this stage, not a lot was known. A very basic principle was known that during the condition of El Nino, you will have the situation where Peru receives rainfall, Australia is dry. During the conditions of La Nina, you will have the condition where Peru is dry, Australia receives very heavy amount of rainfall. But how are they created? That was not known at that point of time. So let us understand that. Now, here briefly, I will tell you, when we talk about normal conditions or neutral condition, this is nothing but a Walker circulation. What we have studied right now under Walker circulation, that is what defines the neutral conditions. Now, these conditions, they get exaggerated to form La Nina, they get reversed to form El Nino. So here, if you take a look at it, neutral conditions, under that is the Walker circulation. Under these conditions, trade winds help accumulate warm waters in the western equatorial Pacific Ocean, while cold waters emerge in the eastern equatorial Pacific Ocean. Due to what? Due to upwelling. Right? Now, these cause rainfall in the region of northern Australia, while due to high pressure, there's a lack of rainfall across the western coast of South America. So this is basically observed under the neutral condition, which is very similar to Walker circulation. Now, here is the important part. Sometimes what happens when you have the development of a distinct low pressure area, this will attract winds, isn't it? You have a distinct high pressure zone and a distinct low pressure zone. This will attract winds. Winds will come. Winds will bring more surface water. So the region of warmer water will keep on growing in size. It will keep on expanding. The region of warm water, accumulated warm water, will keep on expanding with the passage of the winds. Means what? Means the low pressure will get more intense. When the low pressure gets more intense, means what? Stronger winds will be driven. Much more stronger winds means there will be greater upwelling which will happen, means a greater pressure gradient force, and that means a kind of an exaggerated circulation where the warm water area increases, cold water region also experience increase because of upwelling. So this is a condition where the trade winds, they become much stronger. Now, in this condition, the region over Australia, Indonesia, Philippines, etc., they will end up receiving very, very high amount of rainfall. It can cause floods in that region as well. Whereas here you observe that the high pressure which has been created, that is much more exaggerated now. So the Peruvian coastline, the South American coastline, it will experience almost so dry conditions, almost on the verge of drought-like conditions will be experienced there. So that is the condition which we refer to as La Nina. So in the condition of La Nina, you will observe that these winds, they are able to bring more warmer waters, and these warmer waters, they spread over a large area, but colder waters, they also significantly expand. Okay, so this is a kind of an event where the Walker circulation gets strengthened, and it is a very simple cycle. What is a simple cycle involved here? So here you will observe that warm waters means low pressure. Low pressure means attracts winds. It attracts winds. Attracts winds mean more surface water will be carried. Water is carried means increase in warm water region, means intensification of low pressure. Intensification of low pressure. Intensification of low pressure means more winds will be attracted, and this process basically results in significant expansion of the warm water region. And also in the process, when more surface water is carried, means greater upwelling in Eastern Pacific. And when we have greater upwelling in the Eastern Pacific, that means what? That basically means that you will have a condition of high pressure, intense high pressure develops. So the winds and the impact on climate that was to be found in the case of Walker circulation, that significantly intensifies, becomes stronger, and that creates a condition of La Nina. So observe here, these are the conditions where a significant low pressure develops over the western equatorial Pacific Ocean, while an intensified high pressure develops over eastern equatorial Pacific Ocean. In a way, it is nothing but an intensified Walker circulation. And due to this, it leads to flood-like conditions across northern Australia, whereas it brings drought-like conditions across the Peruvian coastline. Is that understood now, Tara? So that is basically La Nina. Observe in La Nina, observe the amount of accumulation which has happened of the warm water, and observe the amount of upwelling. So this area has become very cold. That is why La Nina is oftentimes associated with and is referred to as the phase of cooling of Pacific Ocean. La Nina always helps Indian monsoon, something that we will study in the coming classes. Yes, Nabeen, we can say that. Okay. So with that, I will end the session here for today. Kindly revise it. We meet again tomorrow where we end up or we will complete the portion of El Nino and other atmospheric phenomena. And that is when we will enter into the portion of Indian climate and Indian monsoon. Fair WX refers to weather. So it refers to fair and dry weather conditions. Okay. Sneha, why pronouncing Nina? Hmm. I have to improve my English in that case. Its pronunciation is Nina. That is why we attach that symbol. Why do you think I am attaching that symbol in front of or above N? So this symbol that you associate, that is what changes the pronunciation of it. Okay. It is nothing to do with my weaker English in general. So map pointing we'll do tomorrow. And Kishan, you had a question that I'm confused. You said that upwelling, rich nutrients come from subsurface to surface, which led to growth of phytoplankton and zooplankton, which is very good for fishing. So El Nino is good for economic activity in western coast of South America. No. El Nino basically will bring you low pressure in that region, and El Nino will bring downwelling in that region. Will come to it. Whenever you have upwelling, it will, so conditions of Walker circulation and La Nina, that will bring some amount of fishing and fishing prospects in that region, and income will be augmented. As of now, Lakshmi, I would suggest to you restrict yourself to the portion that we have covered in the class. Please don't get confused when you read multiple sources. Just revise the portion that we have covered in the class. Fair WX refers to weather. I have repeated that multiple times. WX refers to weather. Why Atacama Desert is dry? Sachin, that has got to do with the presence of cold ocean currents, the Humboldt current or the Peruvian current that you have. So cold ocean currents create deserts in the western coast of majority of the continents. We'll come to that when we come to oceanography. Okay. And normal and La Nina conditions have similar conditions, right, Elias? And why warm winds sink in water? Rahul, my dear friend, the question is not clear. If it is not El Nino, then it is La Nina in South America. Not always. Anthony, you can have neutral conditions also which can prevail. In December at Peru coast, no rainfall because of Walker circulation? Yes. Shreyank, does Enzo occur in southern hemisphere or in equatorial region? At equator, immediately to the south of equator. So Coriolis force is almost absent. Anjali, when we cover El Nino tomorrow, you will be aware about the differences better. Okay. Monica, as of now, kindly concentrate on the study from the PPTs and the additional reading materials, more than sufficient. Muhammad, subsea water movement also from downwelling to upwelling is called water current. Yes, that is the thermohaline circulation. And cyclone also take place in La Nina condition. Where? Where cyclone takes place? Cyclones can take place in La Nina condition, but not at equator, because at equator you don't have Coriolis force or no circulation. Uh, Naveen, yes. Tahiti formation is because of oceanic convergence. Yes, very good. Deepak, please repeat ensure from scratch tomorrow. Then, if we ensure repetition from scratch every day, do you have a plan to continue with climatology for the 24 modules, or do we have a plan to move ahead also? So, we'll not do that. We will carry out from the portion of El Nino. And Apurva, I have searched on Google about the unexpected rains on North India in the month of March. It was the unexpected rains in the month of March and April and even May in North India, Apurv, was not due to the factor of El Nino cycle on Mediterranean as you have written. It is because of a factor which we refer to as Western disturbance, and that is something we will be aware of when we come to the portion of Indian geography. Okay. In Anjali, it's correct when always dry desert found in north south, not because of cold current. Anjali, we'll come to the formation of a desert, why cold currents they will form a desert, and why always across the western coast of the continents you will find the formation of a desert. It has got to do with the ocean current significantly. In La Nina, why does warm water sink in water? Why does warm wind sink in water? Wind, why will the wind sink in water? Warm wind sink in water rather than cold water. Where? In La Nina, where is it that the wind is sinking into water? Is the wind sinking here? Are you getting confused by this image? Please don't get confused by this image representation. Look at this image and then ask a question. Here, the wind is not sinking, my dear friend, in Australia. In Australia, the wind is coming towards that low pressure and is rising up vertically. And here it is where you have the colder water, and that is where it is sinking. It is a high pressure. And why exaggeration of Walker circulation doesn't happen every time? Pulkit, that is because of the fact that here, this is sometimes the Pacific gets so heated up in the process that even the region of Eastern Pacific gets heated. That is why you have conditions of El Nino also created. When you come to El Nino, we'll get an idea about that. Pulkit, it is not basically dependent on how many candidates are taking it. If you are basically sure about an optional subject, you are sure about it that you will be able to perform in the top 10 across the country, take the optional subject. Then Munna, in summer, sun is in southern hemisphere. It is not warm the region so that low pressure is created. Yes, it will warm the region. That is why you have warmer surface water, and that is why that warmer surface water will be carried by the trade winds. The Walker cycle is present in Pacific only, Shiva. Okay. Tropical cyclones form only on seas. They dissipate on reaching the land. It can cause damage until it dissipates. Temperate cyclone can form and cause damage. Yes, Rahul, that is correct. Vivek, by December. So that is where we'll end the session here, guys. Why Walker circulation only in the Pacific? Because at the region of equator, it is only the Pacific which is so very wide that it can initiate differential heating and cooling. It is not the case in Indian Ocean. You have a different factor. You have the Indian Ocean dipole which develops. You have an Atlantic Nino, but it is not so distinct as you observe in the case of Pacific. How light winds under high pressure allow valley to cool much more than higher terrain. Valley inversion. How light wind under high pressure. Okay. If you are asking about valley inversion, Shiva, so you have cold winds on top of the mountains which become heavier, which sink down, and then they create that valley inversion. And they replace the light wind which is at the base of it. And Abin, does low pressure over Western Pacific influence low pressure? Yes, that is correct. So that is where we'll end the session here today, guys. We meet again tomorrow. Kindly revise this and come tomorrow, and we take this forward. Thank you for being patient enough. See you again. Take care. Goodbye.